Good morning, everyone. Welcome to Vedantu NEET English. I'm Diksha Kaushal, your chemistry master teacher. So, everyone, let me know if I'm clearly visible and audible to you. Everybody in the comment section, let me know if I'm clearly visible and audible to you so that we can start with the session. Okay. So, today we are going to do organic chemistry naming reactions, the most important naming reactions. So, what I have done already, I have handwritten notes for you, right? So, what I'll do now, I'll pick some very important reactions, right? And some reactions that I have given extra to you that are not very important for you, right? So, according to that, we are going to revise naming reactions. After that, we are going to revise important reagents. Like if you talk about HI, right, that is a very important reagent, but that is not a naming reaction, right? So there are so many important reagents which are not under the category of naming reactions, and students tend to skip those important reagents. So we are going to talk about oxidizing, reducing, all these reagents and some of the hidden gems reagents that are there in your organic chemistry. After that, we are going to solve the previous year questions and some questions that are related to the previous year questions that can be directly asked. Okay, so if you all are ready for that, then let me know in the comment section so that we can start with the class. We hear you loud and clear. That's amazing. So everybody, green hearts in the comment section if you guys are ready for the class. And also hit that like button, right? You can see that over here, that thumbs up, so that I can know that you are completely ready for the class, right? Already it's 92 likes. Let's make it to 100 likes within 5 minutes, right? Okay, yes. Chalo, ready, steady, India, go. Right? Okay. Chalo, now let us start this. Beta, there are some extra reactions that I have written here that you will not see in your books, right? But I'll put cross in some reactions, 3-4 reactions. This cross means just go through that reactions once, but you don't need to take that much load on your head because that has never been asked. But otherwise, all the other naming reactions they have repeatedly asked. Okay. Now, let us see Darzen's and Reed's reaction. I'll combine 2-3 like the reactions that are quite similar to each other. So, one is Darzen and Reed reaction. They are quite similar to each other. In Darzen reaction, what you have is you have ROH, and here you add SOCl2 in presence of pyridine, and you replace this OH with Cl. In the corresponding, you have SO2 and HCl as the vapors. That is Darzen reaction. But ma'am, then what is Reed's reaction? If you see what is Reed's reaction, ma'am, this is Reed's reaction. Let me just show you. In Reed's reaction, you have hydrocarbon, right? In Darzen reaction, you have ROH, right? And here you have SOCl2. Then the products are same, right? In Reed's reaction, you have hydrocarbon, where you have SO2Cl2. Now, what is the name of SO2Cl2 and SOCl2? Let us see that. In Reed's reaction, you use SO2Cl2, which is nothing but anybody in the comment section, what is the name of SO2Cl2? What is the name? SO2. That is sulfuryl chloride. Sulfuryl chloride. Okay, sulfuryl chloride. Okay. Then, ma'am, what is the name of SOCl2? Anybody in the comment section? What is the name of SOCl2? Anybody? SOCl2, let me see if somebody has answered this or not. SOCl2, beta, the name is thionyl chloride. Thionyl chloride. Okay. So, if they give you that this thing has reacted with thionyl chloride or sulfuryl chloride, then the reaction is going to be different. In Darzen, we use alcohol, and in Reed's reaction, we use hydrocarbon. Okay. Okay. So you can remember this. Darzen is like Tarzan. Tarzan is who drinks a lot of alcohol. But Reed's is like very cute girl. Okay. Like we usually say that, okay, boys are alcohol, they drink too much, but girls, abhi to we can see like there is no differentiation only. Everything is going on in this universe, right? But yes, you can remember this. Darzen is a guy who drinks a lot of alcohol, but Reeds is like Ria, who does not drink alcohol. She is only happy with oil, that is hydrocarbon. The desi ghee, she is happy with the vegetable oil, right? That is hydrocarbon. Okay, that is how you can remember the difference. Okay, because naming reaction is all about remembering. Next is some important reaction, that is Sabatier-Sanderson reaction. So beta, usually you must have seen that when you have alkene or alkyne, when you break these pi bonds, here you have to break one pi bond, here you have to break two pi bonds. So when you break these pi bonds, you will see that the answer is going to be alkene, right? The answer is going to be alkene. So here what we will see, you break the pi bond, the answer is going to be alkene. But the name of this reaction, if you use nickel as the catalyst, that when you heat it, the answer, the name of this reaction is called Sabatier-Sanderson reaction. So simple is, if you are breaking one pi bond, then definitely you will need less temperature. If you are breaking two pi bonds, you will need more temperature. Okay, the name is Sabatier-Sanderson reaction. Now, I'll just tell you one more reaction. Anybody who knows what is Birch reduction? Anybody who knows what is Birch reduction? Okay? Birch reduction and Lindlar's catalyst. Why I am teaching you in this sequence? Because I am teaching you sequence where all the reactions are quite similar. Like Reed and Darzen are similar. Now we are talking about hydrogenation reaction. So when you directly use nickel catalyst, then directly it will be Sabatier-Sanderson reaction. Now I don't want to make from alkyne, I don't want to make alkane. I want to stop at alkene, right? I don't want to make alkane. So that is why when you want to do this, there are two ways, right? Because alkene are also of two types. One is cis alkene, other is trans alkene. For cis alkene, you will use Lindlar's catalyst. What is Lindlar's catalyst? Here also you are doing the hydrogenation only in case of PD, but as a catalyst. But here you are using poison. Poison means you are stopping it, right? You are trying to stop the reaction at a certain point. So you are using PbSO4, you poisoned it by sulfur or quinoline or sulfur or CaCO3. Okay, so usually you will see PbSO4 or sulfur in the answer, right? That is going to give you cis alkene, very, very, very important. Then ma'am, how we are going to get trans alkene? Cis alkene you saw, right? Cis alkene, Lindlar's catalyst, hydrogenation is there, but we poison this, right? Okay ma'am, what about trans? Trans is Birch reduction, okay? Trans is Birch reduction. So beta, how Birch reduction is done? Okay, simple, you have alkyne, you add liquid ammonia, lithium or sodium, right? You add liquid ammonia, lithium or sodium, directly what will happen? You will have the formation of trans alkene. Ma'am, what is cis alkene? What is trans alkene, ma'am? I have no idea. Okay, no issues. Cis alkene is sisters who are sitting next to each other, right? So, sisters are sitting next to each other, right? And trans is opposite, okay? Trans is opposite. So, hydrogen is opposite. R and R dash is opposite, right? So, that is trans alkene. Got it, everybody? Understood? Now, this concept I would say, maybe Birch reduction you all have gone through, but this concept might be a new concept to some of you. Okay? This concept might be a new concept to some of you. So the new concepts or new reactions I am writing in here, right? Those who have already done this, let me know in the comment section. Those who have not done this, let me know in the comment section. Yes, very good Rosenmund, very good Sanvi, very good Sanvi. So basically, this Lindlar's catalyst is also used in Rosenmund reduction. Beta, this is not Rosenmund reduction. Rosenmund reduction is when you have C double bond O Cl, you convert it to C double bond O H with this same catalyst. That is Rosenmund. But this is not called Rosenmund. Okay, this particular reduction is not called Rosenmund. It does not have any name. Okay. Now, as I was telling you about a new way of Birch reduction, we have seen this in simple alkyne. Then what about aromatic hydrocarbons? Okay, so when you talk about benzene, it's a very, very simple concept that we will study now, right? That is, you have benzene, same reagent you will use here. See, always in Birch reduction, you are going to break one pi bond. Okay, one pi bond. Even in alkyne, we are breaking one pi bond. Can you see? In Birch reduction, we break one pi bond, and these things are opposite to each other. That means in Birch reduction, the pi bonds, things are opposite. Right here, which is opposite? Two same atoms are opposite. But in this case, what will be opposite? Two double bonds will be opposite. That is how you can remember this. That in Birch, things are opposite. In alkynes, atoms are opposite. In benzene, double bonds are opposite. So here what will happen? After the reduction, two opposite double bonds will be formed here. One double bond will break. Now, if you have electron donating group, if someone is donating the electron, now tell me, if someone is giving you something, someone is like, hey, I have 1,000 rupees, you take it. You'll be like, arey yaar, what a person, yaar, an amazing person. है ना? I'll have like friendship with this guy. Why? Because he is giving me free of notes, free notes, free money, everything he is giving me. So happy you are, right? So when someone is donating you something, right, then you will sit next to them. You will be like, oh my God, you are awesome, this and that, right? So now this double bond is sitting next to it, right? And other one will be opposite always, right? Electron withdrawing. If someone is like, hey, I need this, I need that, I need that, I need this. So you will try to maintain some distance. So every day they are taking advantage. Every day they are asking you for money, this and that, right? Human nature. You will try to stay away from them, right? So away from them means you will have a distance from them. That is why pi bond is here and opposite to this pi bond is here. This is how you can remember electron donating, electron withdrawing groups. Those students who have no idea about, ma'am, what is electron donating, ma'am, what is electron withdrawing, go and watch my lecture that I have done before last week, that is on GOC, right? Complete GOC I have done in that lecture. You can go and watch that, right? Okay, is that clear to everybody or not? Is that clear to everybody or not? Yes. Next we see is, let's talk about Wurtz reaction. Okay, let's talk about Wurtz reaction. Wurtz reaction. So what is Wurtz reaction? Let us see that. So Wurtz reaction is, you use sodium, right? So you have RX, alkyl halide, roxa, right? So here you have roxa, here you have roxa, here you have sodium. To roxa is a girl, okay? Everyone, roxa is our girl, right? Okay. So roxa is having this sodium here. So when sodium, what it will take? Sodium is a like best friend. So best friend, what they will do? They will be like, oh, this guy is very toxic for you. This girl is very toxic for you. Let's take them away from your life. So sodium is like a good best friend. Okay. So roxa was stuck with the X. X halogen is not good in our organic chemistry. Right? X is always X. Okay. Like you say, your X. This is roxa's X. Okay. So we want to take away X from roxa. So sodium will take away X from roxa. X will be eliminated and he will pair. It's like, okay, what we do? This is someone with the X. This is someone with the X. We'll take out the X and we'll pair them up. Similarly, we are doing things here. This is RX. This is RX. X will be taken out and they will pair up together. You will have RR in the end. Okay. Now, here the thing is, ma'am, mechanism is important or not? Definitely mechanism is important for you, right? So what you are going to do in this mechanism? Here you have R free radical. What you have, guys? R free radical that is formed. This thing is very important for you. That what will happen? RX, you will have homolytic cleavage here. Right after that, you will have the formation of two R free radicals. Sodium will also do homolytic cleavage. Then these two and these two will combine together. And here you will have R free radicals will combine together with RR. Now, the important point here is what you will see that always double the number of carbon you have. That means always even number of carbon are there in the product. So always you will have symmetrical or even number of carbons in the product. You cannot form unsymmetrical products here. That is the not unsymmetrical. Yes. You cannot form propane here because mixed products will be formed. So unsymmetrical is not possible here. Right, next is it is a free radical mechanism. Now, let us do some questions here. How they will ask you question in the exam hall. Let us do that. Beta, whenever they are asking you the question how you are going to proceed, okay, whenever they are asking you the question how you are going to proceed. So firstly, so let me just answer this question first. Beta, always form the free radical. Take out from C and X. What I am telling you, from C and X, do this thing. Free radical, this will be taken out. Okay, this is what you have to do in the first step. So here, form the free radical. This is CH2, this is CH2, this is free radical, this is free radical. Two cases are possible here. Two cases are possible. Either it can do intramolecular or it can do intermolecular. Intermolecular means, intra means within the molecule. Intra means within the molecule, that this free radical will combine with this free radical and will give you one ethene. Okay. Other is when you have one more, that is one more intra dot. This is also dot. Here these two will combine together and will give you 1, 2, 3, 4. Okay. Is that clear that you have what is inter, what is intra? Inter means when two molecules, two same molecules are free radical, they will combine together. Intra is when within the molecule you have two. See, here I am telling you those cases where within the molecule you have two free radicals. Okay, so when within the molecule you have two free radicals, either this is possible or that is possible. Ma'am, but the answer will be one only, right? Which will be the answer? So always intra is preferred over inter. What you have to understand? Always intra is preferred over inter. So this is not preferred. Intra is preferred. But here are some cases also where intra is also where inter is also preferred. Let us see what are those cases. And this is what I tell you always, that GOC is very important. Why? Because this thing only those students will be able to understand who have aromatic, anti-aromatic nature. They know the difference between aromatic and anti-aromatic. Okay. Those who don't know, beta, you can watch my detailed lecture, but here I'll tell you what exactly I'm talking about. Double bond, this will make a free radical, this will make a free radical. As I told you, two things are possible. One thing is intra, other is inter, So anybody, what is intra, what is inter? Let me know in the comment section. When we talk about, everybody, when we talk about, right, will be helpful. Arey, definitely. You will trust me on that. You will get organic chemistry from this lecture only. Trust me, trust on me, have faith on me. Right? The way I have combined all the important reactions, important reagents, and important questions from your previous year questions only, I will give you the proof. And also, I'll show you some JEE mains questions that can be directly asked in your NEET exam. Right? I'll give you some very important questions related to previous year questions. Trust me, this lecture is going to be so beneficial for you. When you are sitting in your exam, you will thank me. I can guarantee you that. Right? Okay. So this is intra, this is inter. See, intra means within the molecule. So what is going to happen? This double bond, these two are going to combine together. Intra means you will have this thing. You will have one, right, free radical, one more molecule with the free radical. Then these free radicals are going to combine. Okay, these free radicals are going to combine. Beta, firstly tell me, is this thing clear to everybody how I made intra and inter? Now tell me which is major. Okay, those who are studying it for the first time, they will say, ma'am, intra, ma'am, you said intra is preferred over inter. But beta, one very important thing is, if intra is give you anti-aromatic compound, if intra is giving you anti-aromatic compound, you will say no, because nobody wants to be poor. Okay? Do you want to be poor? You are studying because you want to be poor? No, you are studying because you want to be rich, you want to be a doctor, you want to earn for your family, you want to be financially stable, is it? So everyone wants to be stable, right? We are humans, we want to be stable. So this also wants to be stable. Anti-aromatic is a poor thing. It's most unstable compound. So nobody wants to be anti-aromatic. So this will not be preferred. This will be preferred. If you have anti-aromatic compound as the product, then it will go through intermolecular like combination. Okay, then it will go through inter. Right, so here why ma'am it is anti-aromatic 1, 2, 3, 4 because it is 4 pi electron. Understood? Yes, very good. Inter is preferred. Things are clear to you. Now let us see what is Wurtz-Fittig reaction. What is Fittig reaction? Okay, Wurtz-Fittig. See, Wurtz is alkyl, Fittig is aryl. What I'm saying? Just remember, Wurtz is alkyl, Fittig is aryl. So when you have only Wurtz reaction, you will have two alkyls. When you have Wurtz-Fittig, you will have one alkyl, one aryl. When you have Fittig, you will have two aryls here, right? Otherwise, all the other things are exactly the same, okay? All the other things are exactly the same. Next, we have two very important reactions, that is soda-lime decarboxylation and Kolbe's electrolysis. Okay, what are the two other reactions? Soda-lime decarboxylation and Kolbe's electrolysis. So in both the cases, the reactant is same, but the product is going to be different. Okay, very confusing step here is, one will give you RH, other will give you RR. That is why students usually confuse between which is going to give us RH, which is going to give us RR, and because of this confusion, they lose marks. Right? So let us see this here. First, we have soda-lime decarboxylation, where you will use soda lime, that is quicklime and caustic soda, NaOH. You have this sodium salt of carboxylic acid, that is RCOONA. Simple thing is, here you will have the formation of RH, but in case of if you talk about Kolbe's electrolysis, you have the same thing, RCOONA, right? This is, you are doing electrolysis, but here you have the formation of RR. Okay, here you have R plus 1 carbon, here you have 2 into R carbon. Okay, understood? So this thing is very, very important. Now let us see why this happens. Ma'am, why soda, and how they are going to ask you questions from here. Right, so one simple thing is, when you have, in this case, in case of soda lime decarboxylation, it depends on the carbon ion, because the intermediate is carbon ion. What you will see in your mechanism itself, what will happen here, you will have RCO negative ion, right? It is going to give the electron, it is going to take the electron. Carbon dioxide is liberated here, you have R negative, which is the intermediate, and it depends on the stability. If they ask you rate of reaction in soda lime decarboxylation, that will depend on the carbon ion. Everybody spam carbon ion in the comment section. If they ask you rate of reaction for soda lime decarboxylation, that will depend on the carbon ion. Let us see this question here. GOC is involved, but if you don't know the knowledge of GOC, you don't know the organic chemistry reactions, you won't be able to solve it. And this is what students call, ma'am, the paper was very tough. The paper was this. Okay, so here let us see that. If you see, this is negative, this is positive, this is negative, this is positive. For a carbon ion, you need to have negative. That means someone who is taking away electron from you. Okay, so you need to have electron withdrawing group here. If you see this is electron donating group, right? This is also electron donating. Basically, this is only showing plus I effect. This is showing you plus M and minus I effect. So in comparison to, when you talk about, wait a minute here, rather than Cl, Cl is showing very important thing, beta. I am again from GOC, I am telling you here. Minus I and plus M effect it is showing. Those who have watched my lecture of GOC, tell me minus I or plus M, which is more dominating in case of halogens, because halogens is an exception here. So beta, in this question, they have asked you three things. First, they have asked you the rate of reaction. That means you should have the knowledge that in soda lime decarboxylation, which is the intermediate. First question. Second question in this question you should know is GOC, that what is how acidity matters. It needs electron withdrawing or donating group. Third question is whether you know that halogen is the exception. Usually mesomeric effect is dominating. In this case, inductive effect is dominating. So it shows it is withdrawing the electron, it is donating the electron. Electron withdrawing groups are better. So we will say this is a better. If I say this is B, this is A. So B has more rate of reaction as compared to A. Right? Very good, very good, very good. Meghna, Roshan, Virat, Sanvi, very good. Okay. Next is okay, this to beta simple. I have just told you that this also we can also prepare benzene here, right? In the preparation of benzene also you can see if you have benzene COONA, you do soda lime decarboxylation. This will be eliminated. You will have hydrogen here, and hence you will have the formation of benzene here, right? Then Kolbe's electrolysis. As I told you, same thing. Carbon dioxide will be liberated here. But in this case, it follows free radical mechanism. That is why the end product is RR, not RH. Right? So how does this happen? Mechanism, let us see that. For mechanism, what you need to understand, at anode, it will lose the electrons, right? So at anode, it will lose the electrons. It will give you this free radical. Again, homolytic cleavage will occur here. It will give you R free radical. Ma'am, do I need to cram the mechanism? No. Just remember it is going to show free radical mechanism. After that, RR will combine together to give RR, right? So here what question they can ask you, at anode which is produced, at anode carbon dioxide and hydrocarbon is generated. At cathode you have the generation of H2, okay? H2 is liberated at cathode. This is the question, okay? Then they can ask you what is the medium. The medium of this reaction after the reaction is going to be basic. Okay, the overall medium is going to be basic in the end. These are some of the important questions. At anode, what is generated? At cathode, what is generated? And its intermediate is a free radical, that is R free radical. Acha, do you remember we have done the same thing in Wurtz reaction, that there was R free radical that was formed. Yes, the mechanism was different, but yes, R free radical was formed there as well. That means, can I say that I am going to combine the R free radical here, beta? Can I say that I am going to combine the R free radical here? So, one thing is this kind of question. Firstly, tell me this kind of, that I will tell you after. But firstly, tell me this thing. Okay, I am saying that R free radical you are going to combine here. So, if I say here you need to have a free radical. Free radical was RCOONA is going to give you R free radical. That means this thing will be vanished off. So this you will take away and you will have, take out this CONA and you will have this kind of free radical. You will have this kind of free radical. Now next thing are same as Wurtz reaction. Two of these molecules will combine together. You will have one, right, this benzene, this is CH3, not benzene, then one more of the same ring will combine, right, and this thing will be formed in the end. Is that clear to everybody? What we are doing, same as Wurtz reaction, same ditto copy paste will be there, right? Okay, chal. Now, let us see, ma'am, what you have done here. Acha, mostly in your books, what you will see that from Kolbe's electrolysis, we are forming alkane. But from Kolbe's electrolysis, we can also form alkene and alkyne as well. How? Let us see that. Okay, how we can form that. So, if this is your, if already carbon-carbon single bond is there and from that carbon you have COH and COH, what will happen? This will be eliminated. This will be eliminated. Here you will have a free radical. Here you will have a free radical. Intramolecular will occur just like we did in Wurtz reaction, and hence you will have the formation of alkene. Similarly, in this case also, this will be eliminated. This will be eliminated. Here you will have free radical. Here you will have free radical. They will combine together. You will have the formation of alkyne in the end. Okay, you will have the formation of alkyne in the end. Okay, yes. Two benzene. Acha beta, that is not benzene ring. By mistake, I said benzene ring. This is not benzene ring. Cyclohexane. Okay. Yes. Now next is this also we have done. This also we have done. This also we have. Acha, this we have not done. This I will mark red. Can you tell me why I am marking it red? Beta, because my duty is to tell you everything. but also tell you which is not very important for NEET exam. Okay, all the things that I have done till now are important. This reaction is not important for NEET exam, but please go through this reaction once. That by chance they ask you, that you should know that, okay, yes, ma'am has taught this, at least you will be able to answer the MCQ, right? And they will not ask you very tough question if they ask you, but this is not important. Again, that is why I have marked red over here. If you want to skip, you can skip as well. Simple is here what will happen? Here what will happen? You will have P, double bond O is attached here, CH2 is attached here. In the end, that is the answer. Simple. Okay. So this is nothing but this is phosphorus yellite. Got it? Next is hydration. This is very. All the other reactions that are not marking red and this, that are important only. This you must have seen so many times in your previous year questions. We have three ways of hydration of alkene, right? One is acidic hydration, hydroboration oxidation, oxymercuration, demercuration. In every case, you are going to add OH negative and H positive, right? But the way you are going to add is different in all these three cases. If you talk about acidic hydration, if they have mentioned this reagent, firstly, you will make carbocation here. Okay? Firstly, let us see, you have CH3, C double bond C. Firstly, you are going to make the carbocation here, right? Once you make the carbocation, after that, you are going to rearrange it. If rearrangement is possible, you can also do ring expansion, ring contraction that I told you in the previous lecture. If that is possible, then you have to rearrange. Only then after you will add OH negative on the carbocation. That is a very important part. If they ask you question from acidic hydration, most probably the question will be of rearrangement or ring expansion or ring contraction. So be aware of that, because right now they don't ask simple question from acidic hydration, right? Next is hydroboration oxidation. Hydroboration oxidation, you add BH3, THF, H2O2. This is the oxidation step. This directly, you don't have to make any carbocation. Directly make anti-Markovnikov rule. Now everybody tell me, in anti-Markovnikov rule, negative part is attached where and positive part is attached where? In Markovnikov also. I want to see that in the comment section. By that time, hydroboration oxidation follows anti-Markovnikov, right? And oxymercuration will follow Markovnikov rule. Okay? Hydroboration oxidation will follow anti. You can remember this by B, B for bad people, and anti is also someone who is bad. Okay? So, hydroboration follows anti, and this is oxy. Oxy is something who is good. We are taking oxygen, right? We are happy, right? So it is good. Oxymercuration will follow Markovnikov addition. Okay? So anti, very good, very good. Anti, if you talk about Markovnikov rule, that means negative part is attached to less number of hydrogen. Anti-Markovnikov means negative part is attached to more number of hydrogens here. Okay? Negative to more, negative to less number of hydrogen, that is anti-Markovnikov and Markovnikov rule. Okay? Yes. See, in a good world, negative means someone who is electron rich, they will go to that person who is poor. Okay, you will definitely donate to someone who is poor. But in an anti-world where everything is going wrong, negative person, negative means the one who is very rich, which has electrons to donate. That will go in that direction where already someone is rich. Now to we know, na, rich is getting richer, poor is getting poorer. Why? Because right now we are in Kalyug. Anti-Markovnikov rule is happening right now in our world. Is it? So chemistry also teach you some important things about life. Acha, is this red? Yes, this reaction is red. Why? Because not very important for you. Just go through this. You have CH double bond CH2 NOCl. So Cl will be attached to this position and NO will be attached to this position, which has more number of hydrogens. Okay, simple. Next is Bayer's reagent, very important, right? What is Bayer's reagent? So here you use 4 diluted KMNO4, which has a pink color. Okay, so when you add it on alkene, what will happen? Syn addition will happen, and you will have the addition of OH and OH in both the positions, right? Okay, that is syn addition. Now the pink color of KMNO4 will decolorize itself. That is how you will get to know that this is also a test of unsaturation. You can test the unsaturation with this test. This is also the test of unsaturation. This, you can remember that brown color PPT of MnO2 and glycol appears. That is why pink color will get decolorized. Okay. Next is Wacker's process. Wacker's process, you can see this is, I will not mark it red because still they can ask you this. Okay. So this is, you have ethene, you add PdCl2 and CuCl2, right? This particular group will be converted to CHO, that's it, and you will have the formation of aldehyde from the ethene directly. Okay, from alkene directly. How to prepare aldehyde? By Wacker's process, that is adding PdCl2 and CuCl2, right? Next we have Groove's process. So Groove's process, how many of you know Groove's process? Lucas reagent. Okay, so that is to distinguish 1 degree, 2 degree, 3 degree alcohols. So here what we use anhydrous ZnCl2 and HCl, right? After this, it is going to give you turbidity, that is cloudiness. Now, if you see 3 degree reacts fastest, then you have 2 degree, then you have 1 degree, important thing. So 3 degree is going to your turbidity immediately, right? Immediately. If you talk about 2 degree, after 5 minutes. If you talk about 1 degree, prolonged heating, and that too after 30 to 40 minutes, it will give you the turbidity, or you can say cloudiness. Turbidity, or you can say cloudiness. Got it? Understood? Yes, turbidity. Next, beta, we have some halogen exchange reactions. Anybody, what are the 2 major halogen exchange reactions? One I have written here. What is the other halogen exchange reactions? Let me know in the comment section. Yes, let me know in the comment section. Very good. First is Finkelstein reaction. I am waiting for the other name in the chat box. So Finkelstein reaction. How we remember this? So there is a girl called Roxa, right? Roxa will be like, Finn will be like, hey Roxa, do some fashion na, hai na? Do some nail paint, hai na? Ma'am also has extensions. Right, Roxa, do some nail paint, right? Like Diksha Ma'am, okay? You should have some nail paint and all nail extensions, right? Nail paint we know that is diacetone, right? Then Roxa is like, nahi, I will not do that. Roxa is very aisa nakhrebaaz, very tantrum she is throwing to Finn. She is like, nahi, I will not do that. I am happy the way I am, right? This is just to tell you that how you understand Finn, NaI, diacetone and RX. After that, what will happen? This will get exchanged, X and I will get exchanged, and this will be the answer that you will have here, right? Next is, now after this, what is the important part? That here NaX, why we are using dry acetone? Because NaX, the precipitate, it will precipitate in the dry acetone, and hence pure Ri will be formed. Okay, but if you talk about you have Ri and NaCl, because this X can only be Cl or Br. Okay, why so? Because if you have Ri here, the reaction will not occur. What is the other one? Yes, other one is Schwarz reaction. Okay, so Schwarz reaction is like, now Roxa will come to Swati. Swati will say, hey Roxa. Now Swati is its best friend. Finn is not best friend, right? So Swati is the best friend, and girls always listen to their best friend, right? They will say, go and jump out of that mountain. They will be like, okay, my best friend is telling me, I'll do that, right? Okay, so here Swati is like, hey Roxa, do some fashion, no, right? So here Roxa will be like, okay, some fashion, okay, I'll do that. So for that, Roxa will use some silver chain, right? So here you can use inorganic fluorides for the fashion to attach fluorine here, right? Otherwise, fluorine is very difficult to make because it is very explosive in nature, right? So here you will have the formation of RF. The example is, if you have CHCl3, you replace the one chlorine with fluorine. Here you will have chlorofluorocarbons, that is freons. Okay, chlorofluorocarbons, that is freons, right? Okay, but we follow Diksha Ma'am. Very good. So, next is Williamson synthesis reaction. Beta, mark it very, very important. Yes, every reaction is very important. Beta, Williamson synthesis and HI. If you talk about from ethers, what they ask you, only these two reactions. If you skip rest of the ethers, you just do these two reactions, I can guarantee 99%. They will 99.9% they will ask you from either Williamson synthesis or HI. Right? So what is HI? We will do that in reagents. Right here we are going to do Williamson synthesis reaction. So Williamson synthesis reaction, everybody let me know what is this. This is RH plus you have NaOR dash. So you have alkyl halide with NaO. What is the trick here? So William came to Roxa. William is like Roxa, Rona. Roxa, Rona. Okay, don't cry Roxa. Roxa, Rona. William is saying Roxa, Rona. Roar kar. Roar kar means the heart. Okay, roar kar. Like you have to win the game. So it's like Roxa is very depressed. Roxa is like, I have my exam, what to do, I don't know anything. Then William will say Roxa, Rona. Roar kar. Roar kar. That means you have to win the game. Right? So that is how you can remember this. Right? So here what will happen? Na and X will be eliminated and you will have the formation of this ether, that is ROR dash. Right? Ma'am, then ma'am, what's so big deal in this? Why they are asking this question again and again, and what's so big deal? The big deal is, first thing is this is S10-2 mechanism. Second thing is, it is alkyl halide should be primary. From this particular point, they have asked so many questions that which of the following will not show Williamson synthesis reaction. The one which has alkyl halide as primary will show Williamson synthesis. If your alkyl halide is tertiary, it is not going to show Williamson synthesis reaction. Is that clear to you or not? Is that clear, students? Is that clear? Why 3 degree it will not show, beta? Because it is SN2. SN2 means transition state will be formed, right? So transition state follows steric hindrance. It follows steric hindrance. So steric hindrance means 1 degree, then 2 degree, then 3 degree. So that is why alkyl halide should be primary in nature, not 3 degree. That is the reason. Next is, this we have done now. Now two questions that are quite similar to which thing? Wurtz reaction. Okay? But they have not asked these two questions, but I would say they are not difficult also. Right? So just go through them once. They have not asked it. Right? Frankly, they have not asked it. So I can mark this red, but you don't need to mark it red here. But still, if you are choosing the naming reactions, ma'am, you have done 60 naming reactions. Ma'am, I can't remember all the 60. So I'm marking cross red in some of the naming reaction. You can skip those. But if you can do, please do that. But if you're like, ma'am, I can take that risk, then skip at least these you can skip. But rest of the naming reactions, you can't skip. You can't afford to skip those naming reactions. Right? So here it is RX. Instead of Na, you have zinc here. Right? So how you can remember? Zinc, Germany, and this is Frankfurt. Frankfurt is in Germany. Those who are very poor in geography, that ma'am, we didn't even knew that Frankfurt is in Germany. How can we remember this? So just see, zinc is getting very frank here. Okay? Zinc is very frank. Sodium is not frank here, zinc is frank. Right? So instead of sodium, you have zinc and dry ether, rest of the things are same. You will have the formation of RR. This is same as Wurtz reaction. Right? Now, the problem is in Wurtz reaction, even in Frank-Land reaction, you can't prepare unsymmetrical alkanes. So that is why we have Corey house synthesis. This till now they have not asked this question in last 5 to 6 years. But you should know that if you want to prepare unsymmetrical, they can ask you this, which of the following will give you unsymmetrical alkanes? There will be Wurtz reaction, Frank-Land reaction, Corey house synthesis, and maybe some other reaction also. Right? So out of that, which will be the correct answer? Corey house synthesis. This will give you unsymmetrical alkanes. And here, what you can do? Here you use R2CuLi. The preparation of R2CuLi you can also skip. Right? But remember, R2CuLi is used in Corey house synthesis. That is your Gilman's reagent. So what exactly is there? Kore house synthesis. So there is a house of Kore where Gilman he has invited. Gilman is a coolie. Coolie, you know who is a coolie? Gilman is a coolie. C-U-L-I. Gilman is a coolie who has been invited to Kore's house. So Kore's house synthesis, Gilman and coolie are to C-U-L-I. Okay. Understood, beta? Any problem till here? If you have any problem till here, then let me know in the comment section. If you guys have any problem till here, then let me know in the comment section so that we can start with some questions of diazotization and diazonium chloride reactions. Acha, France in German. Wैसे France is not in German, but still, if you are saying that, we can, I'll say okay. Okay? France is in German. Cute you guys are. Cute you guys are. Okay. So now let us see diazotization. Okay. Let us see diazotization. Achha, here very simple. All the reactions will start from aniline. Okay. Aniline is our, this benzene, you have NH2. Right. Now here, if you are adding NaNO2 plus HCl, or they can also write HNO2. Okay? Any of this they can give you HNO2 directly or NaNO2 plus HCl. Right? The reaction should be between 0 to 5. Beta, very important thing I am telling you here. The reaction should be between 0 to 5 degrees Celsius. Reason is because they have asked, in NEET exam, they have asked assertion reasoning question based on this. That here what you can see, this is at 0 to 5 degrees Celsius because diazonium chloride is only stable at 0 to 5 degrees Celsius. Now, what if you have RNH2? Here again you are adding HNO2. Now here, if you have, again RN2Cl will be formed. Beta, now, very important thing is, this diazonium, aryl benzonium, very important line I am saying here is, benzene, if you have aryl sodium chloride, aryl diazonium chloride, okay, aryl diazonium chloride, then this aryl diazonium chloride is still stable between 0 to 5 degrees Celsius, okay. That is why when you will warm this, it will directly give you alcohol, okay. That's a very, very important reaction. It will directly give you phenol. But you have to warm it above 5 degrees Celsius, only then it is going to give you OH here. But if you have alkyl diazonium salt, that is alkyl diazonium chloride, in this case you don't even need to warm it. This is very unstable even at 0 to 5 degrees Celsius. This is not stable even at 0 to 5 degrees Celsius. So that is why what you will see, directly it is going to get converted to alcohol. Okay, directly it will give you ROH. Okay? These are some of the hidden questions, right? Some of the hidden questions that they are asking. Till now they have asked this in the form of assertion reasoning. They can ask you the same kind of question in the basis of reaction also. Okay? Understood? Acha. Now from diazonium chloride we have some very important reaction. One is sand-Mayer reaction. So in sand you need salt. Sand, salt, sand, salt, sand, salt. That means you will use salt of the copper. So when you have diazonium chloride, you use salt of copper and chlorine. So it will be chlorobenzene is formed. When you use salt of copper with bromine, bromobenzene is formed. When you use salt of copper with CN, then you attach CN here, cyanobenzene is formed. These are called sand-Mayer's reaction. Ma'am, gutter. Do you know what is gutter? Gutter is very smelly. So what you need to do? Oh my God, so much smell. So what I need to do? I need to have powder over there, right? So that is why we will use copper powder here, right? So that is diazonium chloride. The reactants and products are same. If you use HCl here, chlorobenzene is formed. If you use Br here, then bromobenzene is formed. That is Getterman and Samuel's reaction. But here you can't form cyanobenzene. That is important, right? Next is Ball-Schiemann reaction. Ball-Schiemann, beta, she always want to have her hair, है ना, totally ऐसा अच्छा tied up, right? Color her hair, है ना? She has colored her hair. You can see she's sitting in front, or she's standing in front of you, has colored her hair. So Ball-Schie, that means she wants to have fashion on her ball, on her hair, right? So that is why when you see Ball-Schiemann, just remember that in that case you have to add fluorine on the benzene. What you will add here? HBF4, heat it, and you will use diazonium chloride. You will have fluorobenzene in this case. Achha. Ma'am, what if we add HBF4? But after this is Ball-Schiemann, this reaction is Ball-Schiemann, this reaction is not Ball-Schiemann. Okay, only this reaction is Ball-Schiemann. This what I am writing is not Ball-Schiemann. But what if they give you HBF4? After that you are adding NaNO2, then you are adding copper, and then you are heating it. Then the answer is going to be, anybody in the comment section, answer is going to be nitrobenzene. You will have NO2 here, right? So I am also giving you some similar kind of reactions that they can give you, right? Next we have is Hunsdiecker reaction. Anybody, what is a Hunsdiecker reaction? Hunsdiecker reaction is, what will happen here? Simple. Okay, how you will remember this? Bad criminals. So it's someone who is wearing silver chain. Okay, silver chain someone is wearing. Bad criminals will attack on them. They will take out the silver chain, that is AgBr, they will take out. Now when someone will take away the chain from you, they will snitch something out from you. And so what you will feel? You will feel like, oh my God, I'm sweating, right? So that is carbon dioxide will be released here, right? And you will be left with some bad memories. So you have RBR. So this is basically Hunsdiecker reaction. Okay? So this is also called Borodin-Hunsdiecker reaction. So that is why always this is called Borodin something it is. Borodin-Hunsdiecker reaction it is, right? So how you can remember? So whenever bad criminals will attack you, you will have some kind of wounds, right? So you have to apply Borodin on that. So Borodin, Hunsdiecker reaction, remember this by bad criminals attacking on you, right? Okay, understood. Now we have Dow's process. In Dow's process, what you do exactly, beta? Very simple. In Dow's process, what exactly happens? You have chlorobenzene, right? In this you have NaOH aqueous, 623 Kelvin, 300 atmospheric temperature, pressure. So now here what we are going to do, very, very simple. You have chlorobenzene, but ma'am, it has partial double bond character. So it is very difficult to break this bond. That is why we need high conditions, that is high temperature, very high pressure you need here, right, to break this bond and to convert this into ONA. After adding H positive, you will get phenol here. But ma'am, what is the full mechanism? Let us see that here. What is the full mechanism? Let us see that here. So what will happen? Firstly, you have a base that will abstract proton from here, right? When it is abstracting proton, it will give double bond to this side, and hence you will have 2 electrons here. Now, when this carbon wants to have this double bond here, so this carbon cannot have pentavalency. So that is why this carbon will lose this chlorine here, and hence you will have the formation of benzyne intermediate here. The intermediate is called benzyne in the Dow's process. This they can ask you. After this, you add OH negative here, electrons will jump here, right? Then after that, what is going to happen? This negative, right? This H positive is going to change and get its position here, and here you will be left with O negative, right? Then you have base in the medium, that is Na. That is why you will have Na positive, so you will have ONA. After that, add acid here, you will have H positive. That is the mechanism of Dow's process, right? Okay. Next is Ullmann's. Acha, very important thing in Dow's processes. If on the ortho and para position you have electron withdrawing group, that is NO2 group, in that case, the reactions, the conditions will decrease. The conditions will decrease. That means if on all the ortho and para positions you have NO2 group, then you don't need to have high temperature or pressure. You directly warm it, it will give you the answer. Got it? Understood, students? Next, let us do Ullmann's reaction. Again, not important. So I'm just going to mark it red here. Right? Not important. Here you have just like just like fatigue reaction. Here instead of X you have iodine and iodine. Instead of sodium you have here copper, and you will get the formation of biphenyl or diphenyl here. Right? This reaction is very important, that is Cumene's process. So everybody, what exactly is Cumene's process? So in this also you prepare phenol, but this is from isopropyl. You have benzene isopropyl. When you add O3 or not O3, you add oxygen here, you will have a peroxide linkage here, that is OOH, that is given here. After hydrolysis, you will get this kind of phenol, and this is the acetone you will get. So the byproduct is acetone and the main product here is phenol. So both the products are very important, that is phenol and acetone. Both are very important, and this is they are asking frequently from last 2 to 3 years, right? Okay. Next is Cole's reaction and Reimer-Tiemann reaction. So beta, when you talk about Cole's reaction and Reimer-Tiemann reaction, in Cole's reaction also you have phenol. In Reimer-Tiemann reaction also you have phenol, right? In Cole's reaction, you get the preparation of salicylic acid here, which you have COH on the ortho position. So if both ortho and para products are formed here, but ortho product, because of the hydrogen bonding here, we only write ortho product because it is more stable, it is formed as major, right? So now here what you need to understand, you add NaOH, this will be converted to ONA, then you add carbon dioxide, you will have the formation of salicylic acid. Ma'am, is the mechanism important? Beta, the mechanism of Cole's and Reimer-Tiemann are very, 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 very important. Okay? Because they ask you questions directly from the mechanism of Cole's, Reimer-Tiemann, Dow. Till now they have not asked, but chances are, because that is very important mechanism, that is why I have shown you here, right? So do that mechanism, very, very important that is. Now beta, as you can see here, what you have here is you have phenol. Tell me one thing, whenever you react this with any base, what will happen? Base will always try to extract the proton, right? So it will extract the proton from this side. You will have O negative here. Okay? Whenever you have phenoxide ion, it is always going to show resonating structures, right? So the electron will jump here, this pi bond will jump here, and this is the resonating structure that you will have. Beta, in Reimer-Tiemann reaction, till here, the mechanism is same. Okay, phenoxide ion you will form in Reimer-Tiemann reaction also. Till here the mechanism is same. After that, what you are going to do? In Cole's reaction, you add carbon dioxide. We know that this is carbon dioxide. This is the structure of carbon dioxide. This is partially electronegative. This is partially positive, partially negative. This is partially positive. Now here you have negative. Here you have partially positive. That means more electronegative is going to attack on less electronegative. So this is going to attack here, right? Electrons are going to jump here, and that is how this attachment you will see. Okay. Now what will happen? Again, because this hydrogen will shift internally to this position. Okay. This hydrogen will shift, this electrons will jump here, this electron will jump here, this hydrogen will shift internally here, and hence you will have the formation of this COO negative. Now you just add Na positive, this will be converted to ONA. You acidify this, this will be converted to OH. Is this mechanism clear to everybody or not? Beta, what they can ask you is this step. Which of the intermediate is formed here, right? This step is very important. This step is very important, that on which electron rich point, electron rich carbon, the electrophile is going to attack. Now they can also ask you which is the electrophile here. Okay, this carbon dioxide is acting as an electrophile in Cole's electrolysis. These are some of the important questions that they can ask you. Electrophile is carbon dioxide. This is the position next to C double bond O where it is attacking. Right? These are some of the very important questions. Right? Next is the Reimer-Tiemann reaction. Okay, Reimer-Tiemann reaction. So, beta Reimer-Tiemann reaction, it is the reagents. Let me see in the comment section if any of you remember that this reagent is also there in a very important reaction of amines. And I would say a test of amines. Let us see how many of you remember that. Let us see how many of you remember that. Okay. Now, if you see this here, this is phenol. You use chloroform, you use base, right? It will give you salicylic aldehyde. You will have CHO on this position. But you know what's the interesting point? What if they have given you, instead of this, they have given CCl4 plus NaOH. In that case, you will have salicylic acid. You will have salicylic acid as the answer. This point becomes very important for you. Very good, ma'am. This reagent, these reagents are also there in carbylamine test, that is isocyanide test. Very good, very good, very good. Very good. Now I can see that there is something like, I can see the future doctors in the chat box. I can see the future doctors. Okay. So now here if you see Reimer-Tiemann reaction or carbylamine reaction will do the same thing. Okay. So basically what will happen here, you will have chloroform. This is chloroform CHCl3. Now this OH, that is the base, that is going to abstract proton from here. Okay. Base always, what is the work of a base? It will abstract proton, right? What is the work of acid? It will donate proton, right? So it is going to abstract protons, electrons are going to jump here. This is the fast step and hence you will have CCl3 negative as the answer here, right? After this, you're also going to take away Cn negative from this side. This side will jump and hence you will have the formation of very important thing, that is dichlorocarbene, that is acting as a electrophile here. This was your previous year question of NEET, that in Reimer-Tiemann, or I think they have asked in Reimer-Tiemann only, but they can also ask you in carbylamine reaction, what is the electrophile? Which is the electrophile? So the electrophile is dichlorocarbene is acting as the electrophile in Reimer-Tiemann reaction. Now, once you have the electrophile, other things are same as Cole's test. So what exactly it will do? You have phenol. Base is going to abstract proton from here. It will abstract the proton. Electrons will jump here. Is it? You will have phenoxide ion. Phenoxide ion is going to show you resonance. Negative will jump here. This will pi bond will jump here. This is the resonance. This thing same we have done in which reaction? Cole's reaction. Now there we had the electrophile, that was carbon dioxide. Here we have the electrophile, that is CCl2. Ma'am, why this is the electrophile, ma'am? It has lone pair of electron. Beta, these are not lone pairs. If you see carbon, this is Cl, this is Cl, this is 2. 1, 2, 3, 4, 5, 6. 6 electrons carbon has, so its octet is not complete. That is why it is electron deficient and that is why it is behaving as a electrophile. Because electron loving, the one who does not have electron will only love electron. Na? So that is why here you have, this is the electron deficient point that is going to attack here. Basically the attack should be like this. Okay. Let me just correct this. Okay, beta. Being a organic chemistry teacher, okay, that's my duty to correct this. I know this they will not ask you, but still the arrow should always be from more electron. That means the one which is electron rich to electron deficient whenever we are doing the mechanism, right? So here it is, this site is going to attack here, you will have CCl2 and here this is the negative. Now where you can see the negative, can you tell me the negative charge will be there, the negative charge will be there on this carbon, okay? The negative charge will be there on this carbon, let me just write it clearly. Okay, the negative charge will be there on this carbon, right? Okay, because it has only 3 bonds, so that is why it has a negative charge. It needs to have one more bond, right? So what will happen here? Internally, this hydrogen is going to shift here, right? And you will have CHCl2 here. Then when you add OH negative, Cl is going to replace OH is going to replace Cl here. We know that on a carbon, two OH are never stable. That is why what is going to happen here, beta? If you see this, if you want to see this more like beautifully, right? You want to have your concepts clear here, then it will be like this. OH negative will be eliminated, H will be eliminated, double bond will shift here, and hence you will have the formation of aldehyde group here. Then you add acid here, you will have the formation of salicylic aldehyde here. Is that clear to everybody or not? Is that clear to everybody or not? Right? Next is Kirchhoff's reaction. Those who know Kirchhoff's reaction, again, very important. This is your previous year question. This is also your previous year question. Okay? So everybody ready for that or not? Are you all ready for that Kirchhoff's reaction? So this is the hydrolysis, right? In the presence of mercuric ions, right? So when you have CH, let's say this is CH, this is triple bond, this is CH. Okay, or I'll take one more example. Let us see, you have CH3, C triple bond CH. Now you are adding water here. So what will happen? One pi bond will break here. Pi bond will break and it will give you more stable carbocation, that is this one. Okay, wait a minute. Sure. So it is going to give you more stable carbocation. You will have double bond here. This is CH, right? So here you can see that on the carbocation, here you add H2. This will be OH. Okay, isn't it? You will form a stable carbocation. Then you add OH here. Now, beta, the concept that is tautomerism is very important for you here. This is the enol form. So how do you convert it? Wait a minute, let me see. I am getting some urgent. Okay, let us see this. So here you have enol. How you are going to convert the enol form? This is 1, this is 2, this is 3. Okay, so we have to convert this enol form to ketone form, right? So what you have to do, the double bond of this will jump to this side. So this will be CH3. This is C double bond. The hydrogen on first will jump to the third position. So here you will have CH3. Here you will have double bond 2. So that is how this is the keto form, and hence you will get the formation of ketone by Kirchhoff's reaction by the addition of water in the alkyne. Okay, by addition of water in alkyne you get ketone. So this enol form is converted to keto form, or you can just directly write here, this is the tautomerism. Okay, what you need to write here, beta, what is the concept that we have used here is tautomerism. Tautomerism. Okay, students, we have used the concept that is tautomerism here, right? Okay, next. Okay, tell me how many of you remember in today's lecture only we did what is the name of this reagent? What is the name of this reagent? So here what we are doing, you have COCl, right? This H is reduced, this Cl is reduced to hydrogen here. That is, you have the formation of C double bond O H, right? You have the formation of C double bond O and H. This Cl is replaced by hydrogen here. So what is that called? Everybody in the comment section, I can't see your energy. Everybody, what is this called? H2 you are doing. you are basically doing hydrogenation in the presence of a catalyst. Very good. This is Rosenman reduction and the catalyst is Lindlar's catalyst. Lindlar's catalyst. Okay. That is the name of the catalyst. Okay. Very good. Next is Stephen's reaction. So beta, Stephen's reaction is when you have C triple bond. You don't have to do this full thing here. Just remember, if you have C triple bond N and you add SnCl2, you add SnCl2 and HCl, then this C triple bond N is converted to CHO. This is also a very, very important thing. Okay? So I have written this again somewhere here. So I'll just show you that. Wait a minute, where I have written that. Wait, Stephen's reduction, as you can see here, C triple bond N, you have SnCl2, HCl, that is directly converted to through imine, that is converted to CHO. And if you have SnHCl or if you have FeHCl, then that is not called as Stephen. Only if you have SnCl2 with HCl, only that will be called as Stephen. Okay? Understood everybody or not? Everybody understood or not? This also we have done. Chal. Now, where we were at this point, है ना? ठीक है जी. Now, next is Itard's reaction. So, Itard's reaction is when you have toluene and this CH3 is converted to CHO, right, with the help of chromyl chloride, right, CrO2Cl2 in the presence of CS2. Chromyl chloride is used here. Toluene, because you have T here, Itard, so that is why we use toluene. Okay, this is how to remember that what is the starting point here. Next is Gattermann-Koch. So how you can remember Gattermann-Koch? Just remember this is KOCH. So this is CHO. CHO, that means we are doing something here. We are adding CHO here to the benzene ring by adding CO, HCl, anhydrous AlCl3 or COCl. Okay? We are directly by, because see beta, very simple. This is just like Friedel-Crafts acylation. CH3COCl is a stable thing. But if you have HCOCl, this is not stable. This is not stable. That is why in the Friedel-Crafts reaction, we can't just directly add HCOCl. So that is why Gattermann-Koch reaction is there, in which HCOCl is not added, chromyl chloride is not added. Instead, we add CO with HCl. Then you have the formation of benzaldehyde. Is that clear? Is that clear? Next two reactions are Clemmensen and Wolff-Kishner reduction. Clemmensen reduction is and Wolff-Kishner reduction, reactant and product are same. This double bond O is replaced by H2 and H2. In Clemmensen, so what has happened between the Clemmensen? Clemmensen is a person, his son had a fight. So there is a jung. Jung means a war. A war. Jung ho gayi Clemmensen. Between Clemmensen and son, there is a jung. Right? There is a war situation. So Zn zinc amalgam is there. And in war, the conditions are very acidic. The conditions are very bad. So that is why Clemmensen reduction, you have acidic condition where you use zinc amalgam. But in Wolff-Kishner, you can say it's like Bhagwanji, God, right? So Krishna will always give you positive vibes. Krishna ji will always give you positive vibes. So here you have, that is why you have ethylene glycol KOH, that is the basic condition. So the thing is, here you use basic conditions, here you have acidic conditions. Okay, here you use hydrazine, NH2, that is the hydrazine, this is what you use. Next we have three important tests, not four important tests, tolerance test, not exactly five important tests, tolerance test, Fehling test, Benedict test and iodoform test. Okay, so let's do these very, very important tests. Okay, so when you talk about tolerance test here, what exactly is happening in tolerance test? You have RCHO in presence of silver, basically silver silver ammonium complex, it is reacted with OH negative, right? So what exactly will happen here? You will have this silver will be in Ag positive. This silver is like a silver mirror that you will see when you're doing the reaction on the tube, you will see the silver mirror. So exactly this is getting oxidized. Here you can see the oxidation. Here as you can see the oxidation number is decreasing. So this is the reduction. So basically Tollens reagent, this reagent is an oxidizing agent because it is converting this CHO group to COO. Now the question that they will ask you is that which of the following will show tolerance test. So one thing to remember, all the aldehydes, whether they are aliphatic or they are aromatic, all the aldehydes, we can say aliphatic and aromatic are going to show tolerance test. Formic acid, very important, it is also going to show tolerance test. Alpha hydroxy ketone is also going to show tolerance test, right? That is this. Alpha, on the alpha position you have hydroxy. So alpha hydroxy ketone will show you tolerance test. Hemiacetal, that is this, you have RC. On the carbon, you have OR and OH, right? Acetal, because one you have R and other you have hydrogen. So hemiacetal is also going to show you the tolerance test. Very important. Next is spelling test. So firstly, what is spelling test? In spelling test, we use spelling A and spelling B solution. Spelling A solution is copper sulfate CuSO4. Spelling B is alkaline solution of sodium potassium tartrate, which is also called Rochelle salt. So beta, here what is sodium, what is tartric acid? Basically this is tartric acid. CH, COH, CH, COH, and here you will have OH, here you will have OH. This is tartric acid. But when you replace one hydrogen with sodium, one hydrogen with potassium, that is for sodium potassium tartrate. This is the salt now, right? This is reacted with this CuSO4 here, right? And you get a deep blue complex, okay? Deep blue complex. But what you will see when you react this deep blue complex, this spelling A solution is mixed with spelling B solution. You get this deep blue complex. Then you add this into the aldehyde or whatever is giving that reaction. Now what you will see, what will happen, that is going to get converted to reddish brown precipitates, okay, of Cu2O. And which of the following will give you this reaction? Only aliphatic aldehyde. Only aliphatic aldehyde are going to give you this reaction. Okay, only aliphatic aldehydes are going to give you this reaction. Is that clear to everybody or not? Right? Benedict test also given, same, only aliphatic aldehyde. See, what is the difference between Benedict and Felling? Can you tell me? So, Felling solution, you have to prepare it freshly in the lab. So, it was a difficult task. When you will start doing lab work, you will find it very difficult that okay, you have to firstly prepare the reagents, then you have to do the reaction. It takes a lot of time, right? Because also you need to stabilize those reagents. So that is the reason Benedict test was something which you can prepare before the test, also before the practical also. So that is why instead of tartric acid, you use citric acid here. That is the only difference. Ma'am, will they ask us something else? No. Everything else is same. Just remember, instead of tartric, you have citric acid here. Rest of the things are same. You have reddish brown precipitates in the end. Haloform test, very important test, right? Favorite test of NTA, favorite, like they are in love with this test. Why? Because when you say aldehyde will give it, I can't say. Ketone will give it, I can't say. Alcohols will give it, I can't say. So there is no specific branch that this will give this test. So what we say that in that you always need to have CH3, C double bond O, this kind of group, or you need to have CH3, C, OH and this kind of alcohol. If you have this kind of aldehyde or alcohol, only then this test will be given. Otherwise, this test will not be given. Okay, that is the important point, right? Okay, your favorite also, excellent. right? Because this is going to give you a number in the exam, right? So what is the haloform? So when you have this kind of situation, this or this kind of situation, so when you add NaOX, directly they can write NaOX or they can ask NaOHX2, right? Doesn't matter, whatever they write, it's the same thing. Both are the reagents only. This together, when this will combine, it is going to give you NaOX only, right? Now, these are the reagents. It will give you RCOOON, right? That means 1 instead of this CH3, you will have ONA here, and this CH3 will be converted to CHX3. This whole reaction is very important, right? Very important reaction. Now, beta, if you see, if you have double bond, it will never affect the double bond. If you have C double bond C, it is not going to, this is a line from your NCRT directly, and the things that are mentioned in the NCRT automatically becomes very important for you, right? So it is not going to affect the double bond in that reactant, okay? Now, ma'am, if you talk about haloform, acha, from haloform, if the most famous test is iodoform, okay? Most famous test from haloform is iodoform, where you get CHI3 precipitates, that is yellow in color. Rest of the things are same. Usually they ask you haloform test only instead of iodoform test only instead of haloform. Okay, CHI3, that is yellow in color. Very good, Amit, very good. Very good, Sanvi, Roshan, Amit, Aditya, very good. These students, I can see Chanda, these students are very active, है ना? Very good that you are proactive here. Let me see how many likes you have given. Let's make it 200 likes before we complete naming reactions. Okay, that is your target. Share this among your friends and let's make it 200 likes before we start reagents. Okay, that is your task. Right now only share this on your WhatsApp. Everybody here, share this on your WhatsApp. Share this on your Instagram. Right now only, click the screenshot. I am sitting here doing this. Take the screenshot here and put it on an Instagram story. Tag me Diksha__ Kaushal so that this lecture we can share this among a lot of students who can get benefit out of this, right? Not only the NEET aspirants, the JEE aspirants, and even if you're preparing for any other competitive exam, that includes chemistry, this is going to be very important, right? Okay. Next is aldol condensation, cross aldol condensation, Cannizzaro, cross Cannizzaro. Tell me how many of you have the patience to learn aldol? Let us see if you have the patience to learn aldol, because aldol, I can't say reactant product. No, that is not how I can teach you aldol. Aldol needs patience. You have a proper step, and this is a very important reaction from aldehyde ketones. If you have the patience, then I want to see green hearts in the comment section for your patience, right? If you are saying, ma'am, yes, if it takes 5 minutes to understand aldol, I will understand. Let us see that. Okay, Karthi. Roshan is not Ritik Roshan, it's Karthi. Okay, let us do that here. Aldol condensation. Beta, first thing is the reagents. Usually they will give you dilute NaOH, dilute KOH, or OH aqueous. But sometimes they can also give you aqueous Na2CO3, aqueous K2CO3. That also means aldol condensation only, right? Now, ma'am, how aldol condensation is done? Let me see. Chalo. Beta, mechanism, you can skip also. Mechanism, beta, simple thing it is. Okay, let me just show you the mechanism. Not important. I'll give you the steps to understand the product, because product formation is more important in aldol condensation. Otherwise, very simple. Firstly, base is going to abstract proton from the alpha carbon, right? This has one proton, so it is going to abstract the proton. It is going to give the electrons. So this is what you will have. This is what you will have. Now, if you talk about the other molecule, this is the electron deficient. This is electron rich. Okay, that not electron deficient. This is less electronegative, more electronegative. So this negative part is going to attack on less electronegative. You will have the formation of this will attack here. This product will be formed. Then you add water. OH will be added here. Then you take out OH. Okay, all these things. Here you take out OH. Here you take out hydrogen, a double bond will be placed here. All these mechanisms not important, right? Okay, I told you just to show you that, okay, this simple mechanism they will not ask you. What they will ask you directly, the product formation, okay, that is you have CH3, CHO. They are saying do self-Aldol. Okay, firstly learn self-Aldol. Okay, beta, how you will learn self-Aldol? Write a molecule that open the carbonyl group here. Open the carbonyl group in the first molecule. Because you are doing the self-Aldol, open the alpha hydrogen in the second molecule. Okay, open the alpha hydrogen in the second molecule. Don't open the carbonyl group here. This is, ma'am, why you are not writing it like C double bond H? Because you will get confused only, right? So the best part is open carbonyl group, open alpha hydrogen here. This is alpha hydrogen. If you can see, this is the alpha carbon, this is alpha hydrogen. Now simple next step is to connect the carbonyl carbon with the alpha hydrogen. Okay, so you just need to connect the carbonyl carbon with the alpha hydrogen. Can I connect it? So everybody, if you see this here, this is going to be CH3. Okay, CH3 as it is. Chalo, I'll write it here only. Okay, I'll write it here only. So this is nothing but this is CH3, CH3, C. This double bond O is converted to OH. Okay, directly converted to OH. And which hydrogen you have here? This hydrogen. This hydrogen is shifted to this place. So this is directly converted to OH. This H is as it is. This is joined to the alpha carbon here. Then you have CHO here. Right? Then you have to take out water from here. That is the condensation part. Water from here you have to take out. How you will take out the water? I'll write it as it is. I'll write it as it is. That is CH3, CH. This is OH. This is CH2. This is CHO. Beta, how you are going to take out water? From the alpha beta position. Okay. So if you see which is the alpha, which is the beta, this is C. This is the main carbon. This is alpha. This is beta. Okay. So what you will do? You will take out OH negative from this side, H from this side, and hence on the alpha beta position you will have a double bond. Okay, so this is eliminated already, this is already eliminated, and in that you will have alpha beta unsaturated aldehyde is formed. And what is this? This is aldol is formed. This is aldol, this is aldol, this is alpha beta unsaturated aldehyde. Okay, understood? Everybody, aldol condensation is clear? Okay, is that clear? Aldol condensation is clear to everybody or not? Aldol condensation, if that is clear, then let me know in the comment section, because next is going to be cross aldol condensation. Ma'am, in cross aldol, what you will do, beta? In cross aldol, na, first thing is you will have the self aldol products. Okay, self aldol products. Acha, tell me in the self aldol condensation of CH3CHO, what was formed? The product that was formed is CH3C double bond CHO. The product that was formed is CH3C double bond CHO. That is formed here. This is H, this is H. Okay. Now let us see in the aldol condensation of chalo. In the aldol condensation of CH3CH2CHO, what will be formed? You have CH3. I'll just delete it, isn't it? I think I need to delete it only. CH3CH2. Write it open. Okay, beta, write it open. See this. I told you need patience here. Those students who have the patience can only crack this. Otherwise, so beta, no use. Then you can leave this live session. Okay, if you don't have patience to understand this. C double bond O, open. Then alpha hydrogen. So this is CHO. You have written CHO here. CHO. This is the alpha carbon, which has one hydrogen that will be open. This is CH. Then you will have CH3. Why I have written it like this? Is that clear to everybody or not? Why I have written it like this? Because I need to have my alpha hydrogen open here. Okay? So now attach the carbonyl carbon with the alpha carbon. So what I'll do here, this will be CH3, CH2. This C double bond O is converted to COH. So this C double bond is converted to OH. This is linked to the alpha carbon. This is CH. This is connected to CHO. This is connected to CH3. Okay? Now, you need to do the condensation part also. So, take away OH from this side. Okay? A beta position and hydrogen from this side. You will have a double bond formation here. This is what you will have in the end. Okay? This is what you will have in the end. Here I forgot to write one hydrogen here. There should be one hydrogen. Okay? Here also you should have one hydrogen. Okay? So this hydrogen that we are taking out now. Yes. Okay? So that is the final product that is formed from self-aldol. Okay? Acha, tell me one thing. If I do the cross-aldol, two products from cross-aldol. Two products from cross-aldol. So can I write it the cross-aldol product here? Beta, can I write the cross-aldol product here or not? Everybody, can you draw the cross-aldol product by yourself or not? Let us see that. Okay? So let us draw the cross-aldol product. Okay? Let us draw the cross-aldol product. Okay? Everybody ready to draw cross-aldol products here? Okay. So now, which thing you want me to do? Firstly, let us take CH3. Firstly, what I have to do is, let us take CH3 as the alpha, as the carbonyl carbon. Okay? This carbonyl carbon and this alpha I am using. This alpha I am using, so this will be CHO. This is the alpha, so this is going to be, you can write it as CHO. This is C, H, and there is one alpha. This is one CH3. Okay? Now, when you are joining these two together, what you have to do? So, I'm again going to write CHO. Alpha is this carbon. Here you have one CH3, one CH3. This is the alpha carbon. Now, this is one CH3 and two hydrogen. So, one hydrogen I am writing it here, one hydrogen I am writing here. So, I am going to attach this with this alpha. Carbonyl with the alpha I am doing. Okay. Let us see how many of you are able to answer this. So, what you are going to write here, this will be CH3, C. This is converted to OH. Then this is one hydrogen. This is CH. This hydrogen will be taken out. Right. This will be converted to OH. So, here this is CH. You have CH3 here. You have CHO. Then you take out from alpha and beta position, you take out the OH and hydrogen. Okay? So what you are going to get here, this will be C, and here you are going to have double bond on alpha and beta position. That is the product that you are going to get. Beta, is that clear to everybody? This is cross-aldol product. So in cross-aldol, you have two self, two cross, depending upon the product. This is your NEET previous year question only that I am writing here. They have asked you this question in NEET exam, I think 2022 maybe, right? So that is why I am taking this much time to just tell you that what exactly we are doing here. Okay, so now again what we have to do here, now I will take the alpha of this and carbonyl of this. So now what I am going to write, this is CH3, CH2, carbonyl, right? Then I am going to add the alpha of this, that is CHO, this is CH2 and this is H. This is the alpha carbon. So what is our task, beta? Now you have to tell me what is our task. What you have to tell, beta, what is this? Chandu is saying, man, 2020, 2023. 2 years they have asked this. That means latest pattern is this thing, right? So now what you have to do, attach carbonyl carbon with the alpha carbon, okay? So attach carbonyl carbon with the alpha carbon. What is it? So this is going to be CH3, CH2. Beta, what I need to do with this C double bond O? What I need to do with this C double bond O? Everybody let me know in the comment section what I'll do with this C double bond O and where I'll connect this carbon to. Where I want to see that in the comment section what we will do with this C double bond. That will be, yes, very good. This will be converted to OH, right? Then this will be connected to CH2. This hydrogen will leave, right? And here it will be CH. We know that from the alpha and beta position, you will have the elimination, right? So this hydrogen, wait a minute. Oh my God. Omega. Right, so this hydrogen here, that will be eliminated. This OH here will be eliminated. And hence you will have the formation of one alpha beta unsaturated bond here. Okay, ji? Is that clear to everybody? Very good. Pent to enol. Very good. Is that clear to everybody or not? Will you have any problem? What has happened here? Okay. I didn't knew that. Chalo, no issues. No issues. Okay. I think that automatically got deleted. Hai so this is the third product, that is the fourth product, right? Okay. Rest of the things are same, very simple. Next is Cannizzaro. Can you tell me what is the difference between Aldol and Cannizzaro? So Aldol will always have alpha hydrogen, but Cannizzaro will not have alpha hydrogen. No alpha hydrogen will be present here. When you see no alpha hydrogen, that means you are going to do Cannizzaro reaction. Cannizzaro reaction, beta, it is a disproportionation reaction. It is a disproportionation reaction. Okay, ma'am, what do you mean by disproportionation reaction? So, beta, very simple. In disproportionation reaction, one is oxidized, one is reduced. With the same number of hydrogen, carbon, same number of carbon, one will be alcohol, same number of carbon, one will be your salt of carboxylic acid. One is oxidized, one is reduced. Okay, very good. Cannizzaro is no alpha hydrogen. Cross Cannizzaro, beta, what is the mechanism? This is seriously not so important, so I'm just going to delete it here. So I'm not going to delete it. You can go through this. Okay, if you want to go through, the base will attack here. Electrons will jump here. It is going to be OH. Then there will be hydride shift, right? And hence you will have the formation of alcohol and acid. Okay, you don't need to go through all of this, right? Directly what you should know is what is the answer of Cannizzaro and cross Cannizzaro. So if you talk about cross Cannizzaro reaction, okay, very important, ma'am, which one will get oxidized, which one will get reduced? Okay, what is the question here? Ma'am, which one will get oxidized, which one will get reduced? Okay, so always remember the one which is less hindered will be the salt. So if you see this here, tell me beta, this is less hindered. This is less hindered. Okay, so that is why it will form salt and this is form the alcohol. This will form the alcohol. So that is why answer is going to be HCOONA with the same number of carbon. With the same number of carbon, you will have the alcohol, that is CH2OH. Understood or not? Less hindered is always going to form, yes. Less hindered, everybody spam it. Less is going to form salt. Less is going to form salt. Okay. Then simple esterification reaction. Ma'am, what is going to happen? Water. You will eliminate water here and you will get the formation of ester. But the question is, ma'am, from where? You don't have to remember this full mechanism, right? You can go through this once. You can write the mechanism yourself. But what is the important point of this mechanism? That from where you are getting your, you are taking OH, okay? from this point or this point. So you're taking OH from this point or you're taking OH from this point. That is the important part here. If you see this mechanism here, can you see this? If you see this mechanism here, right, what you will see, from this carbon you are taking out the OH. Okay? So always remember, from carbon you take out, from this acid you take out OH, from alcohol you take hydrogen. If you know this step, you don't need to learn the mechanism. That means what is needed, you have already learned it. OH you will take out from acid, H you will take out from alcohol, and hence you will have the formation of ester. Is that clear? Yes. Okay. Is that clear? Okay. Next is Halogen reaction. It feels like some Gabbar is here, not some kind of Hitler is here. Halogen. Someone is telling you some kind of war is happening. So Halogen. So basically what happens here, the alpha hydrogen is replaced by halogen. Okay, alpha hydrogen is replaced by halogen. What you use here? X2 in presence of red phosphorus and water. X2 in presence of red phosphorus and water, we replace it and we'll get the value of, this is alpha mono. What is produced here? Alpha mono halo acid is formed. Okay, that is HVZ, Halogen reaction. Next we have Mendius reduction. So in Mendius reduction you use, basically you do hydrogenation only in presence of nickel, but here you use either sodium amalgam or ethanol as the next reagents. Okay, so here C triple bond N, those pi bonds will break and here you will have H2H2, that is RCH2NH2, amine is formed here. Next is Gabriel phthalimide reaction. Okay, Gabriel phthalimide reaction. Let us see what is Gabriel phthalimide reaction. Okay, let us see that. Okay, ma'am. So see, Gabriel phthalimide reaction, we use this Gabbar. How this Gabbar is formed, that is also important to you. This question they can easily ask you, very important. That is, you have this phthalic acid. You add ammonia into this. This OH will be replaced by NH2 and NH2. So whenever on the acid you add ammonia, OH is replaced by NH2. That is a standard reaction that happens. Okay, so this is replaced by NH2, NH2. When you heat it, this NH3, that will be eliminated. Okay, NH2 plus this hydrogen here, and you will have the formation of this phthalimide. Okay, so now from this phthalimide, when you add KOH, so directly I will just show you the mechanism only. When you add KOH, this H is replaced by K. When you add RX, this K is replaced by R. Okay, what I told you, this is SN2 mechanism, so there is no carbocation that is formed here. So now after adding, once you have this, when you add NaOH aqueous into it, what will happen? So this bond will break, this bond will break. Here you will have hydrogen, here you will have hydrogen, here you will have ONA, here also you will have ONA. That is why you will have COONA, COONA, and you will have 1 degree amine. Now important part is, here you have aliphatic. The question that they ask is, only aliphatic primary amines are formed here. Aromatic primary amines are not formed. Okay? Only aliphatic primary amines are formed here. That too I will say aliphatic. Okay, can you tell me why not aromatic? Can you tell me why not aromatic? This is also better your question only. Why aromatic amines are not formed here? See, if you can see this here, the R that we are adding, this R is getting converted to RNH. Okay? So if you add an aromatic amine, that is this, we know that this bond is very difficult to break because it has partial double bond character. So this CX bond is difficult to break. That is why We can't break this bond and attach it here. That is the reason aromatic amines are not produced here. Right? Okay. Pratibha, thank you so much. Thank you so much. Yeah. Thank you so much. Let me see. We are about to complete naming reaction. How many likes? Let us see that. I think it should have, it's still not, it have crossed 200. Right? I have told you before naming reaction, we have to cross 200. Okay? Chalo. Now, next is, if you see this we have done one very important is, R should never be aromatic in nature, that I have already told you. Okay? Okay. Next is Hoffman bromamide degradation reaction. Very, very important. Again, one of the favorite questions of NTA. That is, you just add Br2 and NaOH into it. This C double bond O will vanish and you will have the formation of RNH2 here. That is, amine is going to get formed in this answer. Okay, amine we are going to form in this answer. What we did? Hoffman bromamide degradation, we added Br2 NaOH. This C double bond O is going to get vanished and you will have the formation of RNH2 here. You will have the formation of what? RNH2 here. Is that clear? Now, ma'am, what is the mechanism? Okay, let us see that. Okay, let us see the mechanism here. So, what exactly is going to happen? Here, why the mechanism is so important? Because some weird step we are going to see in this mechanism. Let me tell you, till now, they have not asked question on the mechanism of Hoffman bromamide degradation. Okay, they have asked question directly on the reaction. So, see the sequence here. Okay, see the sequence. They have asked mechanisms of Kolbe and Reimer-Tiemann. Indirectly, they have asked that. Now, they have asked us the reaction of Hoffman bromamide degradation. Very high chances in this year or maybe next year. Very high chances they will ask you something regarding this step. Okay, that is why I always teach this because you never know. Sometimes, definitely in every year, they ask some 1, 2, 3 new questions are asked. Okay, this might be that new question. Okay, so see this. Okay, with proper logic only I am telling you why they will ask this. So this is the CO amide you have. Okay, base is going to abstract proton here, so it is going to abstract proton. Electrons are going to jump here. Electrons are going to jump here. This is the equation that, this is the compound that you will have. Okay, now Br2, what will happen? Because of this double bond here, it is going to attack on this Br, then the electrons are going to jump here. Otherwise, Br2 does not have any electron negativity difference. But if this attacks here, this is going to jump here. Now, when the electrons are going to attack here, this negative charge is going to jump on this particular sigma bond, and hence this R, C double bond O, single N to this nitrogen. Now you have added this bromine also because this double bond has attacked here. This double bond has attacked here. That is why to fulfill its tetravalency, carbon has taken out electrons from this oxygen. Beta, is this step clear to everybody or not? What we have done here? What we have done here? RCO, NHBr, this you have. Same thing will happen again. Again, base is going to abstract the other proton. Okay. So, base is going to abstract this proton. Electrons will jump here. This electron will jump here. This is the situation. Now, this next step is very important. You have RCO negative double bond NBr. Okay. Now, let us see what will happen. Br will be eliminated. Why? Because firstly, electrons are going to jump here. Then this double bond is going to attack here. This is written wrongly here. Let me just correct it. Here, what will happen? Wait a minute. Okay. This double bond is going to attack here. And because nitrogen now, it will have the full, basically it will have the full, wait a minute, let me just show you that. Chalo, but let us see how we can understand this step. So basically her rearrangement is going to happen. This step becomes very, very important. That is why I told you that this may be your some new question by NTA, right? So here what will happen? This electron is going to jump here, right? This whole R is going to attack here. Okay, what we are doing here, if I just erase their arrows here, right? If I just erase their arrows here, what is going to happen here, beta? What is going to happen? Rearrangement, that is, this electron will jump here and this R negative is going to attack on this nitrogen. This Br will leave from this side. That is why you will have Rn, you will have Rn, Rn double bond, C double bond O. Rn double bond, C double bond O. Got it? How we are able to form this? This is a very, I think this question has been asked. I don't know if in NEET or JEE. This, so they have asked that which of the following was formed in between. So this is called isocyanate. Not isocyanide. This is called isocyanate. Okay, this is a very important thing. Okay. So what is happening? Very different step you can see. Till now, you have not seen this step anywhere in all the mechanism. That is why this becomes very important. This R is going to attack on this nitrogen. So it will be what? It will be what? It will be Rn, because this is already formed a double bond. Rn double bond, C double bond O. Understood? Everybody, is there any confusion in this step? Once you have this isocyanide, then add water. What will happen? This is R, these two pi bonds will break, you will have RNH2 and this will give you carbon dioxide. You will attach one C double bond. Okay? So water, when you add, this will happen and hence you will have the formation of carbon dioxide and amine here. Right? Okay? Yes. Next is carbylamine reaction. So carbylamine reaction, here you have the formation of isocyanide. Okay, the reactants are same, that is CHCl3 and KOH, that is there in Reimer-Tiemann reaction. Reimer-Tiemann reaction. Okay, so what is the electrophile, guys? Let me see if how many of you remember. What is the electrophile here? What is the electrophile? Okay, so this is RNH2. This is the test of 1 degree amines. We test primary amines here. Okay, test for primary amines. Right, when you add this much, what will happen? A isocyanide will be formed, which is having foul smell. Okay, foul smell of isocyanide is formed, right? Yes. What is the electrophile here? That this is the test for this. Very good. Electrophile is CCl2, that is dichlorocarbene is the electrophile here. Very good, Amit, Karti, Pratibha, very good. Sukanya, Chandu, Devi, Meghana, very good, excellent. Right? Let us see the mechanism here. What is the mechanism in this step? Beta, I am teaching you those mechanisms that are important for you. Okay? Here what you have, CCl, till here to we have done. This to beta we have done in Reimer-Tiemann reaction also, how you have the formation of dichlorocarbene. Okay. After that, what will happen? You have this amine. So this is electron rich, this is electron deficient because it has only 6 electron in the octet, right? So this electron rich is going to attack on the electron deficient and hence you will have the formation of NCCl here. Because carbon only have 3 bonds, so it is going to be negative. Nitrogen has 4 bonds, so it is going to be positive. Right. Now, after that, the base is going to abstract the proton from the amine, and this electron is going to jump here, and hence you will have the formation of Rn double bond because the electrons has jumped here now. So this is going to be, wait a minute. So this will be abstracted by the base. This electron is going to jump here and you will have Rn double bond CCl. Again, what will happen here? Once you have this thing, what will happen here in this case? Very simple. This so beta we have seen that proton will be extracted by the base, electrons will jump here. Carbon will have 1, 2, 3, 4. Okay? So what it will do? It will lose 1 chlorine here. Okay, this is the situation that you will get. Now here what will happen? Again the base is going to abstract proton from here, right? Again, one nitrogen is going to, this single bond will be donated as pi bond here, and this one Cl will be eliminated from this side, and hence in the end you will have Rn positive, C negative as the answer. That is your isocyanide is formed. This is isocyanide, this is isocyanate. Okay, so that these things are very important for you, right? Then the next test is Hinsberg reagent. Okay, what is Hinsberg reagent, beta? This is Hinsberg reagent, so I'm just gonna draw it here. You have R, you have primary amine, let us say. You have primary amine R, primary means you have R, N, H2. Okay. Secondary means you have R, N, R2NH. Tertiary means you have R3N. Okay. Here you are adding this Hinsberg reagent, that is ClSO2, and this is C6H5, that is benzene. ClSO2, ClSO2, and this is C6H5. Beta, anybody, how can we distinguish this? If you already know the answer, then let me know in the comment section. If you already know the answer, then let me know in the comment section what we are going to do here. Okay, HCl will be eliminated, HCl will be eliminated. So that is why you will have the formation of Rn, this is H, this is SO2, this is C6H5. Okay, this is R2N, this is SO2, this is C6H5. This is again R. There is no reaction in this case. No reaction. Reason is, here you have hydrogen, that is why reaction occurred. You had hydrogen, reaction occurred. You have no hydrogen, so no reaction will occur here. So now, ma'am, 3 degree, so we know that this is primary, this is secondary, this is 3 degree. Okay, ma'am, in 3 degree, there will be no reaction. But in primary and secondary, what will happen? Here you still have hydrogen, so this is alkali soluble. So this is alkali soluble, right? You don't have any hydrogen or nitrogen, so this is alkali insoluble. Alkali means NH4OH. Alkali insoluble. You will write insoluble here. Alkali insoluble, right? This one is showing you no reaction at all. Okay, very good. Next is azodye test. So azodye test now, beta in amines, so now if you see what I am doing in this class, I mean you just go through that, right? That will be enough for you. Okay, that will be enough for you. Azodye test. Azodye test is again you take out HCl from this side, you take out HCl from this side. What is the dye that is formed? Anybody in the comment section, phenol will give you what color of dye? Anybody in the comment section, phenol will give you what color of the dye? What color of the dye will be formed by phenol? What color of the dye? You take out HCl, so it will be N2. Rest of the things will be attached here. This is the structure. And aniline will give you what color of the dye? Anybody? So if you talk about phenol, we know that phenol. So this will give you orange color of dye. Okay, you can write it orange. Okay, if you write here that is aniline, that is going to give you yellow color of dye. They can ask you the color of these dyes. These are also called coupling reaction. Okay, this is beta naphthol. So what happens again? HCl will be eliminated here. You will have the formation of, this is benzene, this is N2, and here you have one more, this is OH, right? This is, anybody, what is the color of this azodye formed by beta naphthol? What is the color? Very good, orange dye, yellow dye, very good coupling reaction, orange dye, awesome, awesome, awesome. Awesome, Tanu, Devi, Prama, Subhadra, very good, okay, Shruti, very good. Now, this is scarlet red color. Scarlet red color dye is formed here. Okay, scarlet red, very good. Scarlet red or red color dye is formed here. Okay, Next is Hoffman ammonolysis. So simple thing is, firstly you will have amine, right? Firstly you will have amine. Then when you react this with Rx, you will get primary amine. You will get primary amine, right? Firstly you have ammonia. You react this with Rx, you will get primary amine. Again you react this with Rx, you will get secondary amine. Again you react this with Rx, you will get tertiary amine. Again you react this with Rx, you will get quaternary salt. Quaternary salt. Okay, that is called Hoffman ammonolysis. Right? Okay, how you are preparing amines here. Is that clear? Right? Okay, practical chemistry class, ma'am, beta, definitely we will take that. Next is Schotten-Baumann reaction, that is benzoylation reaction. Schotten-Baumann reaction. So everybody, the name of the reaction is Schotten-Baumann reaction. Okay. So here what exactly you do? This is your aniline. Okay. This is aniline, right? Now in this one position, you replace it by COC6H5. That is called Schotten-Baumann reaction. Okay. This is also called benzoylation. Achha, here also I will tell you what is acetylation. Okay. Acetylation. Acetylation is when you have that is not Schotten-Baumann, that is simply acetylation. You have NH2, okay? When you react this with either acyl halide, CuCl, or you react this with CH3CO twice O, acid anhydride in presence of pyridine. You will get the formation of this one N, this is H, this will be replaced by COCH3. That is called acetylation. We will also see what are the uses of acetylation. Okay, understood? Understood, beta? Step in we have already done. Last naming, or you can say distinguished test, is Victor-Meyer test. Okay, last test is Victor-Meyer test. That is 1 degree, 2 degree, 3 degree alcohols we are using here, right? How to distinguish them. You don't need to learn any of this. Just remember, primary will give you red color, secondary will give you blue color, tertiary will give you colorless solution. That's it. Okay, primary red, secondary blue, tertiary colorless. Primary red, secondary blue, tertiary colorless. Is that clear to everybody or not? Beta, we have completed naming reactions, okay? We have completed naming reactions and distinguished test also. Now, I'll be doing some important reagents. Tell me if you want 5 to 10 minutes break in between, right? So, then we'll start with the important reagents and then questions, okay? Okay, ji? Lot of things we are to do, okay? But reagents are not that much. Okay? Reagents are still less than maximum part we have covered. That is naming reactions. Okay. So if you want break, then spam break in the comment section, ma'am. How long more, ma'am? How long more? I think maybe 1.5 hour more. Maybe 1.5 hour more. Okay, because 30 minutes so it will take us to cover the reagents. Then 1 hour it will take us to cover the important questions from these two things. Because if you have done just the naming reactions and reagents, you don't know how to answer the questions, how the questions will be asked. Right? Then what is the use? Right? Okay? So do you want break in between or not? I can see your energy is getting low. I don't want this energy to get low. I want to see the same energy that I saw in the starting of the reaction, in the starting of the class. Same energy I want to see in the comment section that I saw in the starting of the class, right? You have to promise me you will get back with the same energy, all the students that are present here. After this, beta, we are going to do the important reagents and questions, right? Reagents, usually reagents is what we tend to lose marks on because we don't know that how, because in different chapters you have to take out the reagents and see, right, what is the work of this reagent. Okay, so now everybody For all those students who want to get enrolled to NEET crash course beta, and you want to have, because still you have time, so our NEET crash batch is already going on, and we are completing like really good revision out there. If you can see, this is the content that we are providing you for free of cost. What will be the content for if we charge you? Right, so definitely amazing content, mock test, previous year question discussions in the class, doubt solving is happening there in the crash course, right? So if you see the time, what you are going to get in the crash batch, you will get live doubt solving quizzes, 100 plus live sessions, teacher notes, assignments, and DPP's class recordings, and you will also get 30 plus part test and full syllabus test, right? So these are going to be all India test series. We will provide you with 22 tests in all India test series, which have part test, full test, everything, along with the OMR sheets delivered at your home. Then we will provide you with the QR. If you, first thing is, we will provide you with the instant doubt solve, where you can get your doubt solved within 7 minutes. Then we will also provide you with the QR codes, which is a short quick revision, where everything will be provided you, right, in the form of cards, right, and so that you can easily remember all those things, right? And if you see what is the timing, so wait a minute, the batch has started from this one. So timing is 10 a.m. till 11:30, then 12 p.m. to 1:30, then after the break 6:30 to 8, then 8:30 to 10 p.m. you have your 4 classes daily basis, right? Along why we have given you time between, so that you can do your practice as well, self study also you can do. So every Sunday from 2 p.m. to 5 p.m. you have your test here, mock test here, right? And if you talk about the batches here, there are 3 kind of batches: NEET crash combo, and NEET crash pro. So if you want to purchase everything that I have told you, then you can purchase NEET crash pro, which is at 6499 at this point, right? The price may go high, right? So NEET crash combo, that is, you won't be getting AITS, All India Test Series. So for example, you already have All India Test Series, and you already have some teacher, some Didi Bhaiya who can tell you the doubts, then go for crash combo. If you are like, ma'am, okay, ma'am, I have already purchased All India Test Series, ma'am, I already have, ma'am, QR code, QR cards with me, then go for simple crash batch, that is available at 1999. Okay, so all the details are there in the description box. You can go and check that out. The batch beta that has already started from 17th of March. You're already late, so don't get more late and get enrolled into the batch. Okay, so details, everything I have provided you here. Okay, जी? Okay. Chalo. Okay then, ma'am, please zoom out your screen. Some letters are not visible. Let me see. I think now, it is better now, right? Okay. So everybody, now I'll see you all after the break. Break of 10 minutes only I am giving you, right? Not that long break I am giving you, right? So break is only for 10 minutes. I'll see you at 12:30 p.m. Okay? 12:30 p.m. the class will resume. Okay? Where we are going to do important reagents plus questions. Okay? The timer I'll set here only. Okay, the timer has started. Thank you, beta. Lunch, ma'am, lunch. Beta, 12:30 baje, what lunch? I'm giving you break to eat fruits or snacks, whatever. Right? Okay. Okay, so everybody, let me know if I am clearly visible and audible to you. Let me inform the other students as well. The break is over. Okay. Okay. Yes, everyone. Am I clearly visible and audible to all of you or not? Let me know in the comment section so that we can start with the important reagents. Okay, let us start with the very important reagents here. I think the screen is little out of focus. Is it or not? चलो ठीक है, ठीक ही है. Okay. Organic chemistry will be covered. No need to do unit-wise studying. No, no, no. You don't need to do. If you do, that will be better. But if you don't have time, then this is also good. Okay. Now, next is beta reagents. So let us talk about the important reagents here. First is PCl3, PBr3, Pi3. These are very important halogenating reagents which converts OH to the halogen that you have used here. Right? Okay, so if you have ROH, that will be converted to RX, whatever you have used here. These are halogenating reagents. Now, PCl5, which is also a very good halogenating agent, that is chlorinating agent. So, what it does, if you have ROH, that will be converted to RCl. If you have RCOOH, then here also OH is converted to Cl. And if you have RCOOR, that means if you have ester also, then this OR dash will be converted to Cl. So, it is a very important chlorinating reagent. Next we have is SOCl2. So if you talk about SOCl2 and SOCl2 in pyridine, better tell me in which reaction we have used thionyl chloride. In which reaction, what is the name of that reaction where you have used thionyl chloride? Anybody in the comment section? That was Darzen's reactions. So according to Darzen reaction, if you use SOCl2 alone, right, then you have retention of the product. If you use SOCl2 with pyridine, then you have inversion of the product. Okay. Next is very important, that is if you have KNO2, that is K positive NO2 negative, which is ionic bond, or you have KCl. Here also a KCN. I will also write about KCN plus RX. Okay. So what is the reaction that you are going to form? Okay, so here I am completing the most important reactions and reagents. So if you say that ma'am I have KNO2 or KCN, so it is going to show you ionic. Ionic means CN, this will be negative, this will be positive, right? So here because of this what will happen? You will have the answer here. Oxygen will be free to have the bond, so it will be RONO is the answer. Carbon is free to form the bond, here RCN is the answer. But if you react this with RX, if you react RX with AgNO3 or you react RX with AgCN, now tell me what is going to be the answer. If you react RX with AgNO2 or you react RX with AgCN, then what is going to be the answer? So guys, because AgCN or let's say AgCN or AgNO2, these are having the covalent bonds with the carbon, right? So covalent bond you can't break. This nitrogen, see, this is having covalent Ag with oxygen, it is having a covalent bond. Here you have Ag covalent bond with the carbon. So in this compound, oxygen is not free. In this compound, carbon is not free. So what you are going to have? The answer is going to be AgNO2, and here answer is AgNC. Array, ulta I am writing. Here answer will be RNO2, and here answer will be RNC will be formed here, and this is having foul smell. Okay, understood students, got it? So two very important reagents here. Next is alcoholic and aqueous KOH. So how many of you know what is alcoholic, what is aqueous KOH? So if you talk about aqueous KOH, this is alcoholic KOH. Aqueous KOH is going to do the substitution. That means if you have RCl or let's say RX, right? If you use aqueous KOH, it is going to replace it to ROH. That means halogen will be substituted by OH in the aqueous KOH. But if you have alcoholic, so how you can remember this? One KOH who is drinking only water. So he is only going to get replaced. He is only going to replace the X here, right? But one who is totally drunk, a drunk KOH, alcoholic KOH, he is like, okay, I am drunk, I don't know where I am going. So what he will do? He will cause elimination. Alcoholic KOH is a thief. He will cause elimination. He will take out things. So how he will take out things? So if you have things, let's see. You have here CH3, CH2, and this is X. So what is going to happen? This X and this hydrogen will be eliminated. That will be dehydrohalogenation, and hence you will have the answer as this thing. Okay, that is going to be your answer. And ma'am, what if we have different things? Like ma'am, if we have the option to prepare different products, then what can happen? Let's say you have C1, 2, this is X, this is X, this is CH3, this is CH, 1, 2, 3, 4, this is CH2, this is CH3. Now ma'am, we can have two products here, isn't it? Ma'am, we can have two products here, which will be the product that will be formed here. Anybody, this question is also very important, right? So which product will be formed here? One is halogen can be replaced from this position, and this position hydrogen can be replaced. So you will have the formation of CH3, CH double bond CH3, right? Other is that hydrogen can also be replaced from this position. Okay? Then what you will have, you can also have the formation of CH2 double bond CH2CH3. Now what I have written here is you will have ZZ product is formed. That means the one product that is high alkyl substituted product is formed here. High alkyl substituted product means that here you can see on the double bond you have two alkyls. Here on the double bond you just have one alkyl. So this is the major product and this is the minor product. Is that clear? That aqueous KOH, alcoholic KOH, what is the product, what is ZZ product, right? Everything I have told you in this particular reaction. Okay. Next is aqueous KOH, beta, this I have already told you, so it is going to substitute things. So now if you have aqueous KOH or aqueous NaOH, right? If you have RX, it is going to replace X with OH. But what if you have alcohol, you have let's say you have phenol, you have acid, you have carboxylic acid, you have ROH, you have this alkyne, then what can happen here? Okay, then what can happen here? So basically what it is going to do, it is going to give you the neutralization reaction. So what will happen? A salt and water will be formed here. Okay, salt and water will be formed here, right? Okay. Next is you have aqueous NaHCO3. If you have aqueous NaHCO3, then what we are going to do here? Very important. ROH and phenol, they are not going to react with aqueous NaHCO3, but phenol, if it has electron withdrawing group, will react, and RCOH will also react. Okay, RCOH will react with NaHCO3, right? Phenol, if it has electron withdrawing group, only then it will attack. Otherwise, phenol or alcohol will not react because they are not that acidic to react with sodium bicarbonate. Okay. Next we have alkene. Now, if you talk about alkene, it does not react with KMNO4, LiLH4, NaOH or H2SO4. Alkane is a very stable species. But if you have tertiary alkane, that means on that carbon you have 3 CH3 groups. In that case, what you will see, it will react with KMNO4 and it is going to replace this hydrogen with the OH here. Okay? It is going to replace the hydrogen with the KOH here, OH here. Next is, this to beta we have done, and a syn addition of that was Beer's reagent, nothing but Beer's reagent that we have already done in the naming reactions. Next is mild oxidizing agent. Now beta, we are going to study about oxidizing agents. Okay, what is the study? Oxidizing agents. So remember that mild oxidizing agents are like PCC, PDC, CrO3. All of these are mild oxidizing agents. Okay. If you talk about strong oxidizing agents like cold KMNO4, Jones reagent, these all are strong oxidizing agents. Jones reagent is nothing but it is when you have CrO3 in presence of H2SO4, that is the strong oxidizing agent. Right? Okay. Now see one thing here. I'll just give you one simple table here, right, regarding this, how alcohol is going to behave with strong oxidizing agent or with weak mild oxidizing agent. Okay. So everyone, this is the table, this is the alcohol, this is the strong, this is the mild oxidizing agent, how it is going to behave. Okay. So everybody, I want to see your comments in the chat box. What is your answer on that? Right? So here I am talking about mild oxidizing agents. Here I am talking about strong oxidizing agents. The distinguish I have already given you what are strong and what are mild. Okay? These are alcohols. This is our alcohol. Okay? This is our alcohol. So if you see this here, if alcohol is primary, if alcohol is secondary, if alcohol is tertiary. Always remember, primary alcohols are going to give you, on mild oxidizing agents, they are going to give you aldehyde. Secondary are going to give you ketone. Tertiary will show no reaction. That is why tertiary ketones will never, tertiary alcohols will not show reaction with mild or strong oxidizing agents, right? Primary with strong oxidizing agents are going to give you carboxylic acid. Secondary, again it is going to give you ketone only. Tertiary, there is no reaction. Is that clear to everybody? Is this thing clear to everybody or not? Primary, secondary, tertiary on mild and strong oxidizing agents, what they are going to give you, right? And what are mild oxidizing agent? PCC, PDC, CrO3, mild oxidizing agent. Strong oxidizing agents are cold KMNO4 or Jones reagent are strong oxidizing agent. Is that clear? Okay. Now, next part I'll teach you regarding copper. Okay. So copper and MnO2. Okay, let's talk about copper and MnO2. So beta, if you talk about copper at 300 degree, that is 573 Kelvin, that is 573 Kelvin, 1 degree alcohol and 2 degree alcohol will give you the same answer, just like mild oxidizing agent, that is, it is going to give you aldehyde 1 degree, 2 degree is going to give you ketone, right? But what about 3 degree? Anybody in the comment section? If you have a 3 degree alcohol, which is something like this, CH3, okay, which is something like this, that is CH3, okay, I can write it like this. This is CH3, this is CH3, this is OH. Now, it is going to give you which thing? OH will be eliminated, H will be eliminated, double bond will shift here. Can you tell me what is the answer? C double bond CH2, CH3, CH3. That means copper is going to give you alkene. Very good. Copper is going to give you alkene. Okay. Copper is going to give you alkene. You can just directly write it here. Okay. Okay. Is that clear to everybody? It is going to give you alkene. Okay. Next is if you have MnO2 as the oxidizing agent, it is not going to oxidize anything, but it is going to oxidize allylic alcohols to CH. So allylic means you have C double bond C. The carbon that is next to the double bond is called allylic carbon. Okay. So this is CH2, this is CH, this is COH. Right? Okay. This is CH2, COH. Now this will be converted directly to aldehyde, that is CH2 double bond CH CHO. Okay, that will be formed in the presence of MnO2. That means if you have allylic alcohol, this is the allylic position. Okay, this is the allylic position. Okay, got it? Yes. Next is, before hot concentrated, what I'll teach you is ozonolysis, right? So that you can get with that flow. So beta, ozonolysis again a very important and one of the favorite reactions of NTA. So what exactly ozonolysis? What is the simple trick to solve ozonolysis? For that you need to know there are two kind of ozonolysis. One is reductive, other is oxidative. Usually they ask you reductive only, but oxidative only is one step, just do one step more and you get the oxidative answer. For reductive, see here also you will add O3, here also you will add O3, here you will add Zn or Me2S, here you will add H2O2 or directly, this or part I will teach you after some time. Okay? Just remember, in reductive you use O3 with Zn or Me2S. Here you use O3 with H2O2, that is oxidative. Better now let us take example of any double bond, any alkene here. Let us take the example. So what exactly you will have? Let us see, you have CH3, C double bond C, this is CH3, this is CH3. Take a very important example I am taking here. This is H. What you have to remember, whenever you are doing ozonolysis, right? Let's say you are doing reductive ozonolysis. For reductive ozonolysis, what will be the answer, everybody? For reductive ozonolysis, break the double bond, attach double bond O. Break the double bond, attach double bond O on both sides. That is the answer. So let us do that. Let us do that. Right? Break the double bond, that is CH3, C double bond OH. And here also attach it the same way. This will be C double bond O. This is CH3, this is CH3. Okay, that is the answer for reductive ozonolysis. Break the double bond O, break the double bond, attach double bond O. Now for oxidative ozonolysis, what you have to do? Let's say you have oxidative ozonolysis like this. Okay, now what you have to do? Get the answer of reductive ozonolysis, beta. Get the answer of reductive ozonolysis. Just replace that hydrogen which is directly connected to the carbonyl carbon to OH. So here only one hydrogen is connected. So this will be CH3, C double bond O. Simply you can write it like this also, C double bond O. This is OH, right? In this no hydrogen is connected to the carbonyl carbon. So here it is C double bond O, CH3, CH3. Is this thing clear to everybody or not? Is this thing clear to everybody how we are going to do oxidative and reductive ozonolysis? Is there any problem in oxidative and reductive ozonolysis? Now, ma'am, what about this hot concentrated KMNO4? Beta see, as I told you, strong oxidizing agent are cold KMNO4. If ma'am cold KMNO4 is strong oxidizing agent, then hot KMNO4 is so super duper awesome oxidizing agent it will be. Can you see that 3-degree alcohols? We can see that strong oxidizing agents were not able to oxidize 3-degree also. ठीक है. So that means with cold, that is strong oxidizing agent, 2 degrees only going up to ketone, 3 degrees showing no reaction. So if you use hot KMNO4, something weird is going to happen here. Let us see what is going to happen here. And that happening is nothing but this is what I have written here, that hot concentrated KMNO4 will behave the same way as we do oxidative ozonolysis. Okay, it will behave the same way, just the way we will do oxidative ozonolysis. So here's the point, that 1 degree alcohol will give you directly carboxylic acid. Beyond carboxylic acid, you can't get anything, right? 2 degree alcohol, let us see how it is going to behave. Now we know that if you have cold KMNO4, 2 degree alcohol will stop to ketone. But if you have hot KMNO4, it will go further. So firstly, from 2 degree alcohol, just directly prepare ketone. Lest we know that even strong oxidizing agent will only prepare ketone. Okay. After this, you will do tautomerism, because we know that in ozonolysis you need to have double bond. So our task is to somehow get double bond here, right? That is to double bond of C double bond C. So this is your keto form. Now you are going to do tautomerization, that is 1, 2, 3. That means this double bond will jump to this 2 and 3 position. Hydrogen will jump to this first position, and hence you will have enol form here. Hence you will have enol form here. Got it? Now, next thing is, once you have enol form here, what we did in oxidative ozonolysis? What we did in oxidative ozonolysis? Tell me, beta, what we did in oxidative ozone. I'm just going to erase this because I want to tell you the full answer here. So that's why I'm going to erase it. I'm going to tell you every single point here. Break the double bond, attach double bond O. So this will be RCOH. Break the double bond O, attach double bond O. Okay? Plus, here it is going to be C has 2 hydrogens, and here you have double bond O. Isn't it? I told you that hot concentrated H2SO4 will give you oxidative ozonolysis. That means the hydrogen will be again replaced by the OH. So you have to convert these 2 hydrogens. You have to convert these 2 hydrogens, this hydrogen and this hydrogen, to OH. Isn't it? You have to convert this to OH, this also to OH. Okay, so guys, am I visible and audible to you or not? I think something happened, but we will complete this, right? Okay, everybody, let me see where we were. I think we were at this point, right? We were doing this hot KMNO4, this thing we were doing, right? Okay, everybody. Many lines we missed. Which lines you missed? Okay, so everybody, am I visible and audible? Now let's complete this session. We were at hot concentrated KMNO4, right? So I told you that hot concentrated KMNO4 is an even stronger oxidizing agent. So what it is going to do? Firstly, because of tautomerism, this double bond will be there. Then this will break. This will be converted to C double bond O. And here it will be converted to nothing but this will be converted to CH, and you will have double bond O here. Then these 2 hydrogens are going to get replaced by OH. On 1 carbon, 2 OH are never stable. So it is nothing but, can you see, this is nothing but H2CO3. That is mineral acid. So whenever you see H2CO3, it is always dissociated. This carbonic acid is directly dissociated to H2O and CO2. Hence, the answer that we directly write is CO2 plus H2O. That is the work of strong, very, very strong oxidizing agent, that is hot concentrated KMnO4. Next is, ma'am, if we have 3-degree alcohol, then what we will do? So we know that 3-degree alcohol, nothing can happen if we have even cold KMnO4. So with hot concentrated KMnO4, what will happen? Firstly, water will be liberated. Just in case of copper at 300 degrees Celsius, what you used to do, this OH and one hydrogen from here is eliminated. You have a double bond here. So hence you have a alkene here. Then with this alkene, we know that this is CH3, this is CH3, this is CH2. So this is the double bond. So what will happen? This double bond will break. You will have attachment of double bond O here and double bond O here. And hence the answer is going to be CH3, C double bond O, CH3. Basically, beta, this is the answer that you will see. CH3, this is C, this is CH3, this is C double bond, this is CH2. So this bond will break, it will give you double bond O, right? Here you will have H and C double bond O. As I told you, hot concentrated KMnO4 is nothing but you have to convert this OH, H into OH. That is nothing but H2CO3, which is again dissociated into H2O and CO2. That is why directly I have written CO2 here. Is that clear to everybody or not? Is that clear to everybody or not? Moreover, is that clear to everybody or not? Right? Okay. Top lines are not visible. But the top line is nothing is there in the top line. Nothing is there. Okay, this is 3-degree alcohol. That's it. Okay, understood? Got it? Yes, everybody. So that we have done. This also we have done. Right? This also we have done. Then there comes dehydrating agents. So dehydrating agents are like you have concentrated H2SO4, concentrated H3PO3, PCl5, P2O5, concentrated H3PO4 and POCl5. All of these are very, very strong dehydrating agents. So what they are going to do? They are going to abstract minus water here. They are very good dehydrating agents. Next is concentrated H2SO4. As I told you, this is a very good dehydrating agent, but that also depends on the temperature. If the temperature is greater than 170 degrees, so what it is going to do? This is CH3, CH2, this is OH. It is going to take out OH from here and hydrogen from here, and it is going to give you alkene. So alkene is formed. But if you have 140-degree temperature, then what will happen? This will abstract water. It will abstract water, but it is going to take out water from two different alcohols. That is, it is going to take out water like this, and hence you will have the formation of CH3, CH2O, CH2, CH3. That is nothing but that is ether formation. Okay. Next we have is terminal alkynes. Okay. So when you talk about terminal alkynes are basically very, very acidic. This hydrogen is very acidic in nature. So that is why you add ammonical solution into it. It will replace it with Ag. When you add CuCl2, it will replace it with copper. With copper, it is going to get red precipitates. And with Ag, silver, it is going to get white precipitate. So this is also a kind of tolerance test. Right. Next we have is NeHCO3. Right. This question is not at all important for you. So I'll just delete this because this is important for JEE aspirants, not you guys. Okay. Next we have is Tollens reaction also, beta. We have seen that before as well. Hydrolysis. If you have hydrolysis of this Amine or Cn or NC, after hydrolysis, what you are going to get with Amine, you are going to get ketone. This will be replaced by oxygen, right? If you talk about the hydrolysis of Cn, you are going to get, firstly, you are going to get here pi bonds will break, you will have NH2 and you will have double bond over here. Then again after hydrolysis, this NH2 will be replaced by OH. So you are going to get acid here. Next is with NC, again what will happen? All the pi bonds will break here. You will have NH2 here and this will be COOH. So answer will be RNH2 and COH will be formed here. Next we have allylic bromination. देखो बेटा, allylic bromination means on the allylic position there will be substitution reaction. So as I told you, this is the double bond, this is the allylic position. So this hydrogen on the allylic position will be substituted by the halogen in the presence of if you have Br2 or Cl2 in presence of UV light, or you have N-bromosuccinimide, okay, or you have N-bromosuccinimide, only then this reaction is going to take place. Next we have, as I told you, that there is one reaction is Williamson synthesis reaction. The other reaction is HI, okay, the other reaction is the reaction with HI. So what we are going to do here, very important. So this is ROR dash, concentrated HI. What will happen, ma'am? This is H positive, this is I negative. H positive is going to attach somewhere here, right? So what will happen? Either this bond or this bond will break, right? If I say this bond will break, this is, let's say, here you have the attachment of R, let's say I, and here you have the attachment of H. So it is Ri and this is ROH, that is alcohol. But the question is, which bond will break? Whether this bond will break or this bond will break. Who will tell you this thing? These two important lines here. This is a very, very important reaction. Okay. So the important line is, if you have R or R dash, both are primary in nature, then this will follow SN2 mechanism. SN2 mechanism means it is going to show you transition state. It will be a one step. It is going to show you transition state. That is the reason we know that 1 degree is more stable, then 2 degree, then 3 degree. That is the reason where less steric hindrance is there, I negative will be attached to that alkyl. Okay, because in transition state we talk about steric hindrance. But if one of them is 3 degree, then it follows SN1, that means carbocation formation. So whenever you have carbocation formation, it is directly going to follow 3 degree, 2 degree, 1 degree. That means I negative will get attached to the most stable carbocation. Okay. So if you talk about 1 degree, 2 degree, 3 degree, it will get attached to the 3 degree carbocation. Okay. Next is very, very important, two reducing agents. That is Li. I can see the energy is getting down, so I am going to end this lecture. Okay. I don't know why you guys do this. It's not my problem that the studio went off. As soon as studio went off, your energy is like seriously so low that I have to inform you every single day that this lecture is going on, this is going on, join this. I have to motivate you. What is this, guys? Huh? Is this what a teacher deserves? Huh? So I have to inform you every time break is over, this is over, I am okay, now studio is on. Every time someone has to inform you about everything, do we have to spoon feed everything on you? Is this the thing that you want? Are you in 4th or 5th class that we have to spoon feed everything? Can't you just yourself see that the teacher is live here? I was in the lecture before also, let me join back. You guys have zero patience, zero consistency I can see. Only few students here are actually stay here till the end. And I'm very shocked to see this, that you have your exams in just 1 month, and even then we have to motivate you. We have to tell you that it's your exam, you have to study. It's very sad to know that you actually want to be future doctors, but I can't see that thing in the comment section. I can't see that energy. I can see that consistency. I can't see that discipline in you guys. If you actually want to be future doctor, you have to be there at 1 a.m. or 2 a.m. also. This is not how you are going to be a doctor. Frankly, you are like, ma'am, I want shortcuts for everything. Ma'am, a full syllabus, ma'am. Ma'am, 1 hour, ma'am, please teach full syllabus. No patience, nothing, and we want to be doctors. Huh? I think I'll die only if doctors who just want full syllabus in 1 hour. Ma'am, please give us, ma'am, 45 questions that will be there in NEET. Maybe, ma'am, then we are able to clear. Then we'll be future doctors. But the future doctors you want to become, you have to have that patience, you have to have discipline in you, right? So you have to be here without me telling you again and again. I am not here your energy booster, right? You have to have that energy within yourself. I am not someone who can again and again tell you that be, let's do this, let's do that. You have to be on your toes every time the teacher is standing here, right? Okay, yes. Now, then there is LiAlH4, that is the reducing agent, and NaBH4 is another reducing agent. So if you talk about LiAlH4, very important line is, it is going to reduce carboxylic acid, ester, acid chlorides, all of them. It is going to reduce this amide also, amine also, and NO2 also. All of them will be reduced by LiAlH4. But if you talk about NaBH4, see, more important thing is that if you have a double bond, it is not going to reduce that. But if with the double bond you have some electron withdrawing group, then it is going to reduce that, right? Next is NaBH4. So if you talk about NaBH4, very important line, it does not react with ROH, RCONH2 and RCOOR. So if you anywhere see these three compounds, it is not going to reduce that. That reduction will not happen, and hence this is the answer that you will get here. Right? Okay. LiLH4 will reduce, but NaBH4 is not going to reduce ether, carboxylic acid or amide here. In next 10 minutes, if I don't see the janta here, I am simply going to end this class here only, right? Because I am not stupid to stand here when I have a holiday, right? I stand here for you guys for nothing, okay? So I'm not going to teach. If I don't see students here, it's your responsibility. You want to share it, share it. You don't want to share it, just do that. I'll end the class. No worries, okay? So next is Dibble, that is diisobutyl aluminium hydride. So Dibble is also asked to you. This is going to reduce COCl to CHO, CO, that means ether to CHO, CN to CHO and acid to CHO. So all of them will be reduced to aldehyde, right? Whether you have acyl chloride, you have ester, you have cyanide, you have acid, all of them will be reduced to aldehyde, right? Then you have hydroboration, that is B2H6. So this is also acting as a reducing agent only. So if you have this reduction will happen. This will reduce this pi bond. This will reduce acid to alcohol. This will reduce this amide to amine. Other things will not be reduced, right? So all these are very, very important reducing agents. Next is Grignard reagent. So how Grignard reagent is going to behave here? Let us see that. Grignard reagent is going to behave in this manner, that if you talk about Grignard reagent has two kind of reactions. One is proton source. Other is if it sees any carbonyl group here. Okay? So if you talk about the proton source, this is RMgX. Okay? So when it is going to react with some proton source, let's say water is a very good proton source, alkyne is a very good proton source. So with those proton source, it is going to abstract the proton and get converted into the hydrocarbon. But if you talk about Grignard reagent, if it sees any carbonyl compound here, what is going to happen then? We know that this is partially positive, this is partially negative, this is partially positive, this is partially negative. So what will happen? This R negative is going to attack here, electrons are going to jump here. You will have RCOMgX. This is 1, 2, 3. Here there will be R, and after hydrolysis, this is going to get converted to OH. That is how Grignard reagent is going to behave with the ketonic group, or you can say the carbonyl group. Okay, understood? Yes. Next is very important, that is hemiacetyl or acetyl or ketyl or hemiketyl, right? So if you talk about hemiacetyl or acetyl or ketyl, so very simple thing. Let us talk about this aldehyde. You give H positive to this thing, right? That will be double bond OH. You take care again, attack this with one more ROH group. So what will happen? You will have the formation of hemiacetal. In hemiacetal, you have a carbon which is linked to a alkyl, one hydrogen. That is why it is called acetal. Acetal. Al means one aldehydic. That is why it is formed from aldehyde. Okay. So it is one R, one hydrogen, one OH, one OR. But if you add one more ROH, it will convert this OH into OR. Okay, and hence you will have the formation of acetal group. Same is with if you have ketal and hemiketal. Directly you will use ketone here. Same reaction will occur. But in this case, when to this carbon you have two R groups. If you have one R and one H group, that is hemiacetal. If you have two R groups, that is called hemiketal. Okay. If you again react with this alcohol, this OH is converted to OR, then that is called a ketal group. That is called a ketal group. Okay. One question that they can ask you is that if you talk about this CR double bond, this is ketone, right? So if you add ethylene glycol, this is also going to form a ketone. So ethylene glycol, which it is going to form a ketal here, it is going to form a ketal here. So in this case, it is acting as a protecting group. Protecting group. Protecting group means when you have the formation of ketal to protect the ketone here. So this is H, this will be taken out, this oxygen will be taken out minus water, and hence you will have the formation of this ring structure where that ketonic group you have protected by forming ketal. So that is why the advantage of forming ketal is to protect ketonic group. That is a very important question. Okay. To protect the ketone, we prepare ketonic group. Next is cyanohydrin. It is also a very frequently asked question. So this is positive, this is negative. Negative will attack here, electrons will jump here, then you will have the addition of H here, and hence the reaction, the answer that you have is nothing but this is called cyanohydrin. Okay. Next, beta, these kind of reactions. So here what you have, if you have a ketone and if you have a group that is NH2Z, so this oxygen and this H2, that will be eliminated. In the answer, this is C, this is R dash. Here double bond, this is N and Z. That is going to be the answer. Now, according to Z, how it is different, you will have different answers here. So, I'll also give you one simple table here for Z. That is this table. Why can't I see that table here? Wait a minute. I think that table, wait a minute. I'll just give you that table here. Just give me a second. Beta, that is your NCRT table. Those who don't know, pick up your NCRTs and I'll let you know what exactly the table I'm talking about. Okay, I'll just cut. No, not even cut. I have to wait a minute, beta. Okay. I'll show you that table because from that table directly you can see some very important answers. Hoy. How do I get it here? Wait a minute. Directly for NCRT, I am getting that. Okay. Chal. Let us see what is that table that I wanted to show you. Okay, where it is. Here is the table, right? That is a very, very, very important table, right? I thought I have already taken the screenshot, but I think I took the screenshot in some different slide only. So here is the final thing. Okay. So can you see this? Can anybody see this? Right? Okay. Is that visible to all of you or not? Is that visible or not? That is visible, right? Okay. That is visible, right? So basically you have to do this table where Z, different Z is given to you. Z is hydrogen, Z is R, Z is OH, Z is NH2, Z is this NH benzene. NH benzene, you have two nitro group, you have NHCO, NH2 as Z. So different Z, what is the name of the reagent according to that, right? What is Z? It is NH2Z that we are reacting here. This is Z, this is the Z that we are getting, that is reacting here, and this is the Z formation here. So according to the variation of Z, you will attach it here, and these are the answers that you get, and these are the names of those products that you will get. It's a very, very, very important page of your NCRT. Okay, very important page of your NCRT that you must know. Okay. Then next is electrophilic substitution reactions. So here I am telling you that these are the reagents and this is the electrophile that will be formed here. So if you see this here, everyone, if you see this here, wait a minute. Is there any lagging? Okay. So if you see this here, what you will see, Cl2 anhydrous Cl3 will give you X positive as the electrophile. Like you have any halogen here. Concentrated HNO3 H2SO4 will give you NO2 positive electrophile. RCl anhydrous Cl3, that is Friedel-Crafts alkylation, will give you R positive electrophile. RCOCl or anhydride, acidic anhydride, will give you Friedel-Crafts acylation, that is RCO positive electrophile. Concentrated H2SO4 or oleum will give you sulfonation, that is SO3H as the electrophile. Right? Now next is if you have Br2, very, very important thing, that Br2 and water on benzene, on phenol, if you add Br2 with CS2, that is going to give you ortho and para product different, or one ortho product, one para product, where para is going to be the major product. If you have phenol, if you have Br2 water reaction here, you will get tri-substituted product. But when we talk about aniline, you always get tri-substituted product. So how to get mono product? How to get mono product here? That is the major question. For that, we do the acetylation. This hydrogen, if you remember this reaction, I have already taught you in benzoylation, today's lecture only. Okay? We replace this hydrogen with COCH3. Now, this lone pair are already busy in the resonance with the C double bond O. That is the reason they are not very active. These lone pairs are not very active here. That is the reason they will not give major substitution at ortho and para position. That is why only para product is formed after the acetylation. One more example of acetylation is what you will see here, that you have aniline, and in aniline when you do the nitration, you get, see, aniline is ortho para. You should get ortho and para product only. But they are also giving you meta product, that too at 47%. Now, how is that possible? It is possible because we know that on nitration you have concentrated HNO3 and H2SO4, which is a very strong acidic condition. This is a very good base. Now, acid-base reaction will occur, and what will happen here? This base is going to abstract one acid from here and gets converted to aniline ion, which is meta-directing. Because of this aniline ion, you get 47% meta product here. Now, to avoid this situation, what we are doing here, to avoid this situation, what you will do? You will do the acetylation, then you will do nitration, you will get para product, then you will do hydrolysis, you will get only para substituted nitro product of aniline. Okay, so these are the two major examples, major uses and application of acetylation. Now, last one, very, very important, that if you talk about diazotization, when you have diazonium chloride, if you directly want to prepare benzene from it, then either use H3PO3 or ethanol you can use, or directly formic acid you can use. You will directly get the formation of benzene from diazonium chloride. Okay, is that clear to everybody or not? Is that clear? Now, beta, do you want to do questions or not? Let me know in the comment section. If I see that students are interested, they are answering the questions, then I'll take up questions. If you are not interested in answering, only me speaking here after 3-4 hours of teaching, right? I have told you everything. All the important reactions, reagents I have taught you. After that, if I see students are not answering, right, they are not interested in answering the questions, I am not going to teach you the questions. Questions I will give you for homework, you do it yourself. Okay, now I'll see in the comment section. If you are ready, then only I'll proceed further. If you are not ready, I will not proceed further. There is no major things that, okay, I have to read this today. There is no pressure on me or on you. If you want to do it, good. If you don't want to do it, good for you. Okay? Yes. Want to do questions, ma'am? Amit is there. Then I borrow mobile from my cousin brother to watch your live only for your teaching, ma'am. Thank you so much, Karthi. Thank you so much, beta. Okay. Do questions, ma'am. Roshan, that means Karthi is interested. Chandu is interested. What about the other students here? I want all of you to be interested here, guys. Right? Okay. Let us see. How many of you? How many of you? If you guys are ready, then spam this chat box with ready. Okay, only then I'll do the question. Otherwise, I am standing here. Okay, otherwise I am standing here. Only 3-4 students are interested. Only 3-4 students. Then so I can take their class on my Zoom meeting or somewhere. I can teach them. Isn't it? Only 3-4 students are interested. Let us see, I am sitting here quietly, standing here quietly. Sukanya is interested. Okay, Pratibha is also interested. See, the way you are telling interested is so slow that I can even name all the students here. Okay? I am so relaxing here. Okay? I'll see if you guys are okay with that only there. Okay? Because you know what exactly is there? Because ma'am, so much content is provided on YouTube for free. That is why we don't value it. Okay, when something is on for free, we don't value it. If I say, give me this much money, I'll teach you these questions. You'll be like, oh my God, oh my God, oh my God, there's something very important here. That is the problem. That is the problem in the mindset. Okay? Chalo. Let us see and start those questions for my students who are interested. First is 1-bromo-3-chloro-cyclobutene on reaction with 2 equivalent of sodium in ether will give you. 2 equivalent of sodium in ether. What is the name of this reaction? That means they are talking about Wurtz reaction. 1-bromo-3-chloro-cyclobutane is nothing but this is 1-bromo-3-chloro-cyclobutane. After this, what is the free radical that you will get is this one. See, We know that with intermolecular, what you can get, for intramolecular, you will join these two free radicals, this is what you will get. With intramolecular, right, you will get something else only, but we always prefer intramolecular over intermolecular. That is why this will be the correct answer. Hence, answer is going to be C is the correct answer here. Okay. The final answer is going to be C is the correct answer. Okay. Next we have, next is, I think that was repeated or what? Achha. Okay. Next question is, you have this as the reactant. But very good questions I have picked up. Okay, that's why I get disappointed to see these kind of reactions. Okay, only few students, that hurts me a lot because it takes a lot of hard work to prepare all this for you, right? So this is the reactant ZnHCl CrO3. Then you have okay. Now, what is ZnHCl? Anybody who can tell me ZnHCl? ZnHCl, this is zinc amalgam, HCl, Clemenzin reduction, right? That is going to Clemenzin reduction. Beta, what is Clemenzin reduction? This is Clemenzin reduction. After this, what is this? This is aromatization. Aromatization. That means when you have Cr2O3, basically Cr2O3 is going at very high temperature, it is going to convert things into aromatic ring. So what will happen here? What will happen here? I don't know why I'm getting again this. What is happening here? Some booth is there or what? First question. Hai. What is this? Question. Then again what you have this. Hai na? Okay. I think some booth is there. In my studio, some booth is there who is not going to let you study. Okay. So firstly, this C double bond O is converted to two hydrogens here. Clemenzin reduction. After that, what will happen? Aromatization. So this is 1, 2, 3, 4, 5, 6. This will get converted to a 6-membered benzene ring. And as you can see, 1, 2, 3 on the third position, you have this group that will be attached as it is. That is aromatization. So answer will be B is the correct answer. Let me see. Yes. Okay. So answer is A is the correct answer. Okay. Next question is, I think something has happened to the board. It is behaving very weirdly, right? Okay. In the Hoffman bromamide, now we have Hoffman bromamide degradation reaction. The number of moles of NaOH and Br2 used per mole of amine. Which is the reaction they are talking about? Hoffman bromamide degradation. Now they are asking you the moles here. For that, directly what we will see, directly beta, what we will see is this reaction here. I don't know why I am not able to click anywhere. See, when you guys are not interested, this is what happens to the class. That's why they say, na, when you take things for granted, things will tease you, right? Things will also take you for granted. So now the board is taking you guys for granted, right? So that's why I say when the studio is working right, then please behave, right? When you don't behave, studio also is behaving, showing tantrums to me, right? So this is when you have 4 moles, okay? 1 mole of bromine, 4 moles of NaOH are used for 1 mole of amine production. So here the answer will be, that answer is going to be that C is the correct answer. 4 moles of NaOH and 1 moles of Br2. Okay. Let us see the next question here. That is the major product obtained on interactions of phenol with sodium hydroxide and carbon dioxide. Phenol with sodium hydroxide and carbon dioxide. Can you tell me what is the name of this reaction? Beta, this is nothing but this is Kolbe's electrolysis. Okay? Nothing but this is Kolbe's electrolysis. So in Kolbe's electrolysis, what is the formation that you have? You have the formation of salicylic acid. Is it? You have the formation of salicylic acid here. Okay? Yes. I don't think so. Today you have the kismat कि मैं आपको पढ़ा सकूं. The major product formed in the following reaction. So can you see this reaction? The major product that is formed here. Everybody, what is the major product that you can see here? Major product. As you can see, अरे भाई क्या दिक्कत है? HDFC Bank. HDFC Bank, what it has to do with me, I don't know. What's their problem? Take this insurance, take that insurance. I don't want to take any insurance, bro. Not interested. Let me teach. Okay. Now, next is the major product formed in the following reactions. The major product formed in the following reactions, can you tell me? Dilute NaOH, that means either it can be aldol or cross-aldol. So here on the alpha position you have this CH3. Here also on the alpha position you have this CH3. So can you tell me what is the major product that will be formed here? Everybody, shall we do it? The major product that is formed in the following reaction. So what we have to do? We have to take the major product now. Wait a minute. This is CH3. This is benzene. COCH3. So what you can do here? Cross aldol you will do. Right? So this is the reaction mechanism is. Firstly, we know that here what will happen? Base is going to abstract one H positive from this side. Now the question is, ma'am, this is CH3, C double bond OH. Ma'am, here this is also alpha, this is also alpha. Which alpha we have to use? That is the major question here. So we will use this alpha because here benzene is attached. So benzene is going to take away more electrons, making this hydrogen more acidic. So that hydrogen will be extracted, which is more acidic in nature. So that is why here this hydrogen will act as the alpha, and hence here you will have CH2, and after this what will happen? The other part is going to attack here, right? That means here you will have CH3, C double bond O, right? What will happen? This is CH3, C double bond O, H, and this is going to attack here. So what will happen? This will be converted to COH. This is H, and here alpha is going to attach. This is CH2, right? And this is C double bond O, right? And here it is CO. This is benzene. Okay. From the alpha and beta position, we will abstract this water. So here you will see a double bond, and this is going to be the final answer. Okay, and this is going to be the final answer. If they ask you aldol condensation, right? So that is going to be the final answer here, and hence you can directly answer this, right? Okay. But I think we should do these questions some other day only. Okay? I don't see board cooperating with me. I don't see you guys interested in that. Give me a minute. I don't know what is the issue. Okay? I'm seriously not understanding the issue here. I'm not able to delete anything. I'm not able to use this. So it is getting very, very, very irritating for me as well. Right? So what I'll do, one thing, I'll just save this here. Right? Chalo, let's try one more time if we are able to do this. This is my last try. If this happens, your kismat. Otherwise, beta, we will do this in the next class. Okay? Let me see. Let me see if now I am able to, move the questions, because I am not able to move the questions only. Right? Okay. I think now it's fine. Because of that happened, the thing that happened in between, I think because of that, this file got disrupted. Okay? So I'll just, on one page, there are 2-3 pages that I am like getting open. Again, this is the same thing. Okay. Wait a minute, I'll just open one new page here, right? With that, if I am able to solve, then it would be great. Otherwise, I think we have to end this. Okay? So I'll just see that what exactly is the issue here, what is happening here, right? Okay. Ma'am, how to get notes, ma'am? Beta, I am to not even sure will this file will get saved or not. Trust me on that. There's no idea what is happening here, right? Because of that one sudden fluctuation, this file got disrupted. So I'm not even sure. That's why I'm right now my heart is like beating very fast. Because all the hard work, all the handwritten notes will be lost. Hai. So it is saved successfully. Now let us see. Oh, whoops, OBS crashed. This is what I was thinking that. Okay. Let us see if we are able to import the questions here or not. This is very, very irritating. Very, very, very irritating, beta. If you are on my position, you will see how irritating is to make all the notes firstly, then see all these problems in the class. Isn't it? Isn't it irritating? Yes, ma'am. Very irritating. Okay. Now let us see if we are able to see the questions in sequence. I think we are able to see the questions in sequence now. So let us see this. Let us complete this. Okay. Now let us speed it up and let's complete these questions. Right? Okay, everybody. Not so many questions we have. Let's complete these questions. Okay. So first is the product A and B. Now everybody please speed it up. Right? The product A and B in the reactions are C2H5NH2CH3KOH ABCr. So if you can see here, this is primary amine. This is nothing but carbylamine reaction. In carbylamine reaction, you have the formation of isocyanide, and along with that, you have the formation of H2O and KCl. So answer is going to be A is the correct answer. That is C2H5NC and H2O and CN, right? Next is okay. Next is match the list here. So this is the list, right? This is diazonium chloride with CO2Cl. That is the Sandmeyer's reaction. So E is 2. Okay, if you see A is 2, then what about B? Diazonium chloride in the presence of copper powder. That is nothing but Getterman reaction. So B is 4th. C is you have Rx plus Na with ether, you have the formation of double of this. That means this is nothing but Wurtz reaction. Okay, so C is 1 and D is you have Rx and Na, but here you have aryl chloride. So that is why it is called Fittig reaction. So D is 3rd. So answer is D is the correct answer. Next is the compound C7H8 undergoes the following reaction. So the compound that is C7H8 that undergoes the following reaction. This is the reaction. So what is C7H8? Right? So how you will say C7H8? We know that C6H6 is benzene. If you take out one hydrogen, that will be this. Now you subtract C7H8 minus C6H5. The answer is going to be C2H5678, that is 3. That is why if you see this will be 6 now, this is going to be CH3. That is how you will get to know that to this benzene you have the linkage of CH3. That is nothing but that is toluene. Okay. So toluene is reacted with Cl2. What you will get? You have the formation of CCl. Right. Then this is reacted with Br2 in presence of Fe. So what exactly? Because this is a meta-directing. This is meta-directing. So here on the meta position, you will have the formation of Br. After that, you add HCl and zinc here. Then this CCl3 will be reduced to CH3. And hence, in the end, you will have the formation of meta-bromotoluene. What is this? Meta-bromotoluene. Next question is, hydrocarbon reacts with bromine by substitution to form alkyl bromide when by Wurtz reaction is converted to gaseous hydrocarbon converted to less than 4 carbon. So basically they are saying there is a hydrocarbon, some hydrocarbon is there, reacts with bromine by substitution to form alkyl bromide. It forms alkyl bromide. Okay, R, you have some RH that forms RX, right? After that, by Wurtz reaction is converted to gaseous hydrocarbon which has less than 4. Less than 4 means either it can have 3 or 1 or 2 or 1. We know that in Wurtz reaction, 3 is not possible, only even number are possible. That means 2 is the only possibility. And we need to double the number of carbons. So if here you have 2 carbons, here you should have 1 carbon. So here it should be CH4. They are asking you what is that hydrocarbon? That hydrocarbon is nothing but CH4. So answer is going to be D. Very good. D is the correct answer. Next is an alkene. You have an alkene A on reaction with O3 and ZnH2. Now can you tell me what is this reaction? That is nothing but reductive ozonolysis. Gives propanone and ethanol, right? What is now they are saying it gives propanone and ethanol in equimolar ratio. Okay? Addition of HCl to alkene A gives B as the major product. The structure of B is going to be. So if you see this here, students, they are saying you have the structure of propanol and ethanol. Ethanol, right? This is ethanol, not ethanol. So if you see this is going to be CH3, C double bond O, CH3. What is ethanol? That is C double bond O, H, that is CH3, right? Reverse this reaction, okay? In ozonolysis, you break the double bond, you attach double bond O. Here you break the double bond O and attach double bond, one double bond here. This is going to be the initial answer, right? Now they are saying this is the A that after ozonolysis is giving you propanol and ethanol. After this, they are saying that addition of HCl to this alkene A gives B. Now you have to answer what is B. You are adding HCl into it. So whenever you are adding HCl, tell me that will follow Markovnikov addition, right? Negative part will be attached to less number of hydrogens. So less number of hydrogens means this negative part will be attached here, and this is the answer in the end what you will get. Is that clear to everybody or not? Is that clear? Okay? Yes? So next question is the most suitable reagent. The most suitable reagent for the following conversion is you have alkyne and you need to convert it into cis. So for cis, what you need to do? For cis, what you need to do? For cis, what you need to do, guys? For cis alkene, we add Lindlar's catalyst, that is H2PD and quinoline. That is A is the correct answer. Okay. Next we have an alkene on ozonolysis give methanol as one of the product its structure is. That means methanol means it should be HC double bond OH. Okay, that is methanol. Okay, this is methanol. So if you want to have methanol, then any of this should break. This will, when this double bond will break, this will definitely give you methanol. This will not give you, this will not give you, this will not give you. Because here when you break it, so it will be double bond O and 2 hydrogens. So answer is going to be A is the correct answer again. Right? Okay. Next is which of the following can be used as a halide component for Friedel-Crafts reaction? As a halide component. Okay? Friedel-Crafts reaction. So if you talk about bromobenzene, see, in the halide component of Friedel-Crafts reaction, that is Rx, okay? In Friedel-Crafts reaction, this bond we need to break. We can't break the bond of bromobenzene because of the partial double bond. Chloroethene also, if you see, this is chloroethene, it is also going to show you resonance. That is why you can't break the bond of chloroethene either. You can't break the bond of chlorobenzene also. Isopropyl chloride, you can easily break this bond, right? You can easily break this bond and this will be converted to this particular isopropyl cation, that is your electrophile. Okay, so that is going to attack here. So answer will be isopropyl chloride is possible here, right? Very good. Next is which of the following compounds shall not produce propene by reaction with HBr followed by elimination or wait a minute. Which of the following compounds shall not produce propene by reaction with HBr followed by elimination or direct only elimination reaction? So it should not produce propene. So let us see all of these reactions. If you see this, right, here when you add HBr, it will be converted to this. After that, there will be elimination and it will give you propene, right? Talking about this, when you do the elimination reaction here, again, it will give you the answer propene. Here also, here it will not give you propene. If you see this, you add HBr here. So, HBr will be added in this case, right? Here you will have H, here you will have the addition of Br, right? This compound is formed. After this, you will have the conversion of this into, this is enol form, okay? This is converted to keto form, okay? So, you don't have the preparation of propene here. So, answer is going to be CH2, C double bond. Oh, that means B is not going to show you propene. So, answer is B is the correct answer here. Next is the compound that will react most readily with gaseous propene. Gaseous bromine. Which is that compound that is going to react with gaseous bromine. Gaseous bromine means it should have allylic substitution. So, allylic compound, that is this compound which has allylic carbon, that is only going to react with gaseous bromine. So, if you see this here, this structure, okay, if you see, this is nothing but C double bond C, CH2, CH2. Okay, this is 4 carbons, and here all of them are alkane. Okay, so there is no double bond here. This is also C2H2 means C triple bond C, this is H, C, this is H. C3H6 means you have C double bond, this is CH3, this is H, and this is CH2, which has allylic position which can be substituted by the gaseous bromine. So we can say that D is the correct answer. Next is you have an example of sigma bonded organometallic compounds. Sigma bonded organometallic compounds. So RMgX. That is an organometallic compound which has a sigma bond with the carbon. So answer is Grignard reagent. D is the correct answer. Okay. Next is identify A and predict the type of reaction. So you have to identify A here. Okay. What you have to identify? A here. So what is the kind of reaction this is? Anybody in the comment section? What is the kind of reaction? So you have OCH, you have Br. This is a very strong base here. Okay? This is a very strong base. So what it is going to do? This base is going to abstract the proton here. Right? When it will abstract the proton, electrons will jump here. It will give you benzene. Right? After benzene, right, what can happen? Again, you have NH2. Either it can attack on this side or it can attack on this side. Okay? But what we will see, if it attacks on this side, you will have the formation of double bond NH2 and you will have negative here. If it attacks on this side, you will have NH2 formation here. Now, what you will see, more stable as negative charge is close to the electron withdrawing group. Right? So, this is your electron donating group. Right? So, now here, this is more stable because this negative charge, as you can see, this is the double bond and this is NH2 here. Okay? So now we can say incoming neutron ends the same, C on this side, leaving group is present. So this is not sign substitution. So answer will be C, that is simple substitution reaction. It is going to be, and you are going to have the attachment of NH2 on this side, on the meta position. Okay? Next is the reaction. This is the reaction that is given to you. They are saying in this reaction, you firstly react this with NaH, right? So H is replaced by Na. Then you react this with Me, I. Then you have the formation of ether. So can you see this is nothing but this is RONA and this is nothing but this is RX. So this is Williamson synthesis reaction. So answer is B is the correct answer. Okay. I can see you guys answering here. Now this is from that table that I told you. One table that I told you now, from here the questions can be asked. So that is this table where you have X. Here you have the reaction of copper at 573 Kelvin. Okay. Then it gives you A. Then A is giving silver mirror test. If A is giving silver mirror test, that means it is either aliphatic or aromatic aldehyde. I don't think so. In this C2 carbon, 2 number of carbon, aromatic is not possible. Sorry, aryl is not possible. So that means it is aliphatic, right? So that means this is definitely an aldehyde. This is definitely an aldehyde. What is the aldehyde that can be formed here? CH3, C double bond OH. This can be formed. Okay? We know that if you have alcohol, then if you want to get aldehyde, this alcohol needs to be primary alcohol. So primary alcohol with 2 hydrogen is nothing but 1, 2, this is OH, this is H2, this is CH3. 2 carbon, 3, 4, 5, 6 hydrogen and 1 oxygen. That means this is also we have predicted. Now this aldehyde on reaction with OH negative, that means on further aldol condensation they are saying. This is aldol condensation. This is nothing but this is aldol condensation. On aldol condensation, it is going to give you which thing? CH3, C double bond O. We know that here it is going to react CH2H, CHO. So it is going to give you CH3, C H double bond C. Beta, this we have seen before also. Why it is so? I am directly writing the answer here. Why? Because aldol condensation, I have already told you how to do this self-aldol when we were doing the naming reactions. Okay. So that means Y is also clear to us. Now, let us see. First is A is ethanol. A is aldehyde, that is ethanol. This is eliminated. This is eliminated. From there only we got the answer that this is the correct answer. Okay, you can verify with different products also. Now they are saying if this aldehyde that is having this kind of product, okay, is reacted with this thing. Okay. Now what will happen? This O and this H2 will leave, and hence you will have the formation of N, NH, C double bond O, NH2. Okay, that is semi-carbazone is formed here. Okay. वैसे तो even if you know just A, then also you could have answered this. But still I have answered it fully. This is your previous year question. Next is the heating of phenyl methyl ethers with HI produces. Phenyl methyl ether with HI. This is phenyl methyl ether. Okay. When you have HI, this is positive, negative. We know that out of this only this bond can break. So this will be H, this will be I. So answer will be phenol and CH3I is formed here. Right? Next question is the compound A on treatment with Na gives B. Now you have some compound A that on treatment with Na will give you B. With PCl will give you C. B and C reacts together to give diethyl ether. Okay. There is some compound A. On treatment with Na, it gives B. So basically, I think A is your alcohol. So if A is alcohol, if I say A is alcohol, only that case, if A is alcohol, let's say, if from the option I am checking it, so then this is going to be ONA. Okay. With PCl5, it will give you C2H5Cl. Okay. This is RONA, this is RX. They together by Williamson synthesis, they will give you C2H5O, C2H5. That is the ether, diethyl ether that I have formed. That means the answer is going to be C2H5OH, C2H5Cl, and what is C? Wait a minute. What is A? This is A, na? A, they are saying this is the compound A that on reacting with this give B and with PCl5 gives C. Acha. Then A is C2H5, B is C2H5ONA, and C is C2H5Cl. So answer is D is the correct answer. Okay, D is the correct answer. Right? You have to see this also, what they have named A, B or C, what is the name that they have, donations they have given us. Right? So now in the reaction, this is the reaction. What is, firstly tell me what is the name of this reaction? Phenol to salicylic aldehyde. The name of the reaction is Reimer-Tiemann reaction. In Reimer-Tiemann reaction, you have dichlorocarbene as the electrophile. Right? Next is compound A, that is C8H10O, is found to react with NaOI. Beta, firstly, so you have to see from yellow precipitate, I got a hint that they are talking about iodoform test. Okay? A compound A is found to react with NaOI produced by reacting Y with NaOH. Okay. Yields a yellow precipitate, characteristic smell A and Y are. देखो बेटा, NaOH with I2 will give you NaOI. Okay? So that means this is going to be I2. Now they are asking you what is the A. Beta, A we know that it should have either it should be CH3 C double bond O, or it should be CH3 C OH and H. Okay. Firstly, if you see all of them are alcohol, so alcohol should be like this. So it should be CH3, CHOH, which is there, CH3, CHOH. So that means answer is going to be A is the correct answer. Got it? How you're going to answer frequently, okay? How you're going to answer things fast. Okay, these are the two options. Double bond O I can't see anywhere. Alcohol should be CH3, CHOH. CH3, CHOH, only option is this one. So answer is A is the correct answer. Okay? The structure of intermediate A in the following reaction. Beta, what is the process name? This is nothing but Cumene process. So in Cumene process, to this hydrogen, you have the attachment of peroxide linkage. So this is COOH. So answer is going to be A is the correct answer. Again, next is the correct structure of product A. The correct structure of product A formed in the reaction. So this is the reaction. They are asking you the correct structure of product A. Anybody in the comment section? The correct structure of product A in the following reaction. The correct structure of product A in the following reaction. Anybody? So what we have here, this is double bond O, double bond. This is H2C. I think that is not clearly visible, so I'll just write it here. This is C double bond O. This is double bond O. So they are saying you have H2 gas, right? And you're using PD carbon ethanol. So basically what you are doing here, you're reducing the double bond. Okay. So you are not affecting ketone part here. So that will stay as it is. You are just reducing the double bond part here to the hydrogen part. Right? Okay. So answer is A is the correct answer. Okay. Okay, students. Now we are doing the last question here. Question was slightly not visible. Which of the following reagents will distinguish cis cyclopentane 1,2-diol from the trans isomer? What is the question? Which of the following reagents will distinguish cis cyclopenta to 1,2-diol? That means the diagram that we have is cis cyclo, that means on cis position you have OH. So the answer is given to be aluminium isopropoxide, acetone, ozone, or MnO2. So here acetone is going to distinguish this. How? Because of this acetone, what will happen here? This oxygen, this hydrogen, and this hydrogen will be eliminated here. So this is only possible if both the OH are on the cis position. Okay? That is only possible if both the OH are on the cis position. Is that clear to everybody or not? Yes, students, is that clear or not? That is clear? Okay? Okay? Chalo. So guys, that's it for today. Today we have done all the naming reactions. Okay? We have done all the name reactions. We have done all the reagents. We have done some questions based on that. Okay? The PDF will be provided to you maybe by Monday, right? Because today I need to see that what happened to the PDF, why it is, I have to, make the changes in the PDF. Then I'll provide it to the team. Then it will be there in the description box. Where, ma'am? Wait, let me just show you that. Where it will be provided to you. Just give me a second. So here it will be provided to you. If you see, this is the lecture that is going on. Hai. Do click on the like button here, and here what you will see in the description box, here it will be provided to you, right? Now if you see this here, fill the form to meet your favorite master teachers. You can go and fill the form to meet your favorite teachers here. Then if you see that our crash batch is already going on, okay? NEET 2025 crash batch, beta, it is already going on over here, right? That is just at 999, okay? That is available just at 999 to you, right? Crash batch is already going on here. If you talk about, ma'am, what about if we are preparing for NEET 2026? For NEET 2026 students, then DNA batch for 2026 is also going on. The enrollments has started because this batch is entirely for that year. So that is why the cost is 3,999. Okay, for now, for your 2025, we have this batch that is at NEET Crash Book Crash, that is at 999, and for 2026, okay, the batch for 1 year that is available at 3999. Okay, everybody, is that clear? So all the things will be provided to you here in these batches, right? Rest of the things are, if you're looking for any test series, the link is in the description. You can go and watch those test series here. Yes, very good that this live is filled with green hearts. I'm very, very happy to know that, right? Okay, so just give me a minute. Yes. Okay then, students, till then, bye-bye. See you all in the next class where I'm going to take up isomerism, and uh, there I'm going to take up geometrical stereo, all the isomerism, how to calculate the structures, geometrical isomers, optical isomers, stereo isomers, structural isomers, everything we are going to take up there in that lecture. That is going to happen on Monday at 5 p.m. Okay, at 5 p.m. in the evening on Monday, I'm going to take up that lecture. Till then, bye-bye, take care. This is Diksha signing off, and I want to see all these comments that you are giving me here. Pratibha, Roshan, Devi, right? All of you write it down in the comment section. Do you like this session or not? I would love to see your comments in the comment section. Till then, bye-bye, take care.